This is a deep dive into grid-based games. We are building game menus. We are learning how to implement local multiplayer. We are writing our own custom AI to control the opponents. And as always, we are walking extra mile in extra style, giving everything custom animated visuals. All you need is a code editor and a web browser. Let's build games and learn JavaScript at the same time. Let me show you some of the cool and crazy things we can do when we really understand the code we are writing. This class is beginner friendly, but a basic knowledge of HTML, CSS and JavaScript is needed to get the maximum value. Click the like if you want me to make more projects like this. The game we are building today is a 4-player battle arena. Fight. Let the hungriest snake win. The game grid is responsive and it will adjust to any screen size. We can run the game in full screen mode. We have a game menu where we can choose what creature will the snake look like. We can give each player a custom name that will appear up here on the scoreboard. We can choose if we want the player to be controlled by keyboard arrows, WSAD keys, or by computer AI. This game can be played as 1 player versus 3 AI opponents or 2 players on the same screen, 1 on each side of the keyboard, similar to how some games were played in the 90s and in early 2000s before everything was online. We will be able to choose from 3 difficulty settings for the computer AI opponents. We will implement a set of fun sounds. When designing a game, we have to think what is the main action the player will be taking, and we have to make sure it feels good. In this game, the main action is eating. When the player eats something, we give it a crunch sound and a small burst of particles. Notice that sometimes we get a negative sound and a set of dark particles. That's because some food items are not really edible. Most foods give player a score point and make the snake longer, but eating the spiky shadow snail will actually cost us a score point, and it will remove 1 body segment from the snake. We will also measure game time and implement other tricks and techniques you can reuse to build many different types of games. Join me if you want to discover all of that. The battle arena will be fully responsive and I will adjust its grid-based layout to any screen size. So for the background, we will be using a seamless repeating texture. You can download it in the resources section below. If you inspect the image, you will see it is seamless when repeated both horizontally as well as vertically. I put my images into assets/images subfolder in my project and I link them from there. We will be using sprite sheets to animate the world and the characters, so I need JavaScript to run only after the entire website with all its elements, including all resources such as images, scripts, and style sheets was fully loaded. I will only set my canvas up after the load event has fired. Canvas can be set up easily using the following 2 lines of code. First, I create a variable I call, for example, canvas, and I point it towards my canvas element using its ID. Then I can take that canvas variable and I call built-in getContext method on it, passing it 2D as an argument. This will initialize so-called 2D rendering context, a set of built-in methods and properties we can use to draw shapes on canvas. I set canvas width to 500 pixels. I can see that canvas resized, so we know all our code is working. I set height to 500 as well, for now. When I resize my browser window, this happens. Let's say I want to make sure that the entire canvas is always fully visible. I can give it max height property and I set it to 100%. This will basically just scale the canvas down if needed to make sure it's always fully visible. I do the same for the width. If I set canvas width to 1500, it will make sure it still fits, and it will only show canvas at the full size if the browser window is wide enough. We will have a more sophisticated way to resize canvas and to adjust it to the current screen size to make sure it always fits, but this would be the simplest, crude way to make the canvas somehow flexible. There are a few fundamental things that we need to understand. When we know how this works, drawing and animating on canvas will make so much more sense. I will make canvas full screen. As the web page loads, I will set canvas width and height to the same size as the width and height of the browser window. This will only set the size on the initial page load. If we resize the web page after that initial load, the canvas will stay at that original size. If I reload the page, the canvas will adjust to the same size the browser window is currently. You can see the repeating texture we are drawing with CSS is automatically filling any available space. Perfect. There are a few CSS properties like background size and background repeat that we can use to change how the background image behaves. But in this case, the default way it repeats to fill the canvas background is exactly what we need. I will structure this project as an object-oriented codebase because we are including many cool features and I want this codebase to be well organized, flexible and scalable. Game class will be the main brain of this codebase. We will manage the state of the game and the state of all game objects from here. I can define the game class outside the load event listener as long as I make sure I only instantiate it inside after the page has loaded. I will show you in a minute. We are building a flexible and responsive game. This game always needs to see the canvas element and be aware of its size. I can also bring context as an argument, so we can directly draw on canvas from anywhere inside the game class. Game class constructor is a special method that will run once when we create an instance of this class using the new keyword. It will expect canvas and context as arguments, and inside it will convert them into class properties. I will actually call this property this.ctx. It will point to this variable. We will do that soon. Game will have width and height properties, and I make sure that the size of the game is always the same as width and height of the actual canvas element. I create an instance of the game class inside the load event listener. I use the new keyword, which will look for the class with that name, and it will run its constructor code once, line by line, from top to bottom to set the game object up. I can see it expects canvas and context, so I pass it canvas from line 11 and ctx from line 12. I console log this game variable that holds an instance of the game class, and I can see it has all the properties. All is working well so far. It's good to use console logs step by step like this to spot any potential errors and typos as soon as possible. Class constructor runs once when we create an instance of the class using the new keyword. It runs all the code we put in there from top to bottom. I can take advantage of that, and I can also put some code in here that is not directly responsible for setting up the game object. Maybe some code that I just want to automatically run at the same time as my game object is created. I can even put event listeners in here. When the game object is created, using the new keyword, automatically apply an event listener for window resize event. Standard event listener that will listen for resize event on window object. Whenever the browser window resizes, this callback function will run whatever code we put in there. I can see the console log firing when I resize. Event listeners create this auto-generated event object. To use it, I just need to assign it a variable name, and JavaScript will automatically know what I want. Standard would be event or E. If I console log it, we can see when I resize the browser window, event object is auto-generated and it contains all kinds of useful information about the event that just happened. Current target of this event is the browser window. When we resize, the new size of the window is stored here inside inner width and inner height properties. Let's just console log e.currentTarget.innerWidth. We can see that value as it changes when I resize. Whenever we resize, I want to resize the actual canvas element itself to those new updated dimensions of the window object. I have access to canvas variable from line 16 through this.canvas property on line 3. So I take it and I set its width to e.currentTarget.innerWidth. This will result in an error. Cannot set properties width. It is because inside this callback function, this keyword is the window object and there is no window.canvas property. I need to access game.canvas for this to work. This keyword needs to represent the game, but right now it is representing the window object. One way to make sure that this keyword inside this callback function points to the game object, even though we are calling it from the window object, is to use ES6 arrow function syntax here. One of the special features of the arrow functions is that they inherit this from the parent scope. This is so-called lexical scoping. This keyword here will point to the game instead of window. JavaScript scopes are one of the more advanced features of the language. If you are a complete beginner, don't worry about it too much, but make sure you watch some courses covering scopes and closures eventually, because once you understand that, everything in JavaScript will make much more sense. Brackets are optional if we are passing only one argument to an arrow function, so I can remove them. Now, when I resize the width, canvas is being resized as well to always cover the whole browser window. Let's put this logic into a separate method, because maybe I will need other things to happen as well when we resize. For example, the positions of our 4-player characters to make sure they are always within the visible game area. Custom resize method will expect the new width and height we want to resize to as arguments. Inside, we take this.canvas from line 3 and we set its width and height to these new values. Here, I will call this new custom method. It expects width and height, so I pass it current target width and current target height. When the resize event fires, we call our custom resize method and we pass it the new width and height of the browser window. This method will resize canvas to those new sizes. The repeating texture we set up in CSS covers the entire canvas area, whatever its size. I can remove the black border. After we resize canvas, I need to make sure that width and height of the game is also set to those same updated values. It's a good practice to round the values up or down to the nearest integer, a number without decimal points. Canvas is more efficient if we avoid drawing shapes at sub-pixel values. I think in this case these values come as integers anyway, but this will make sure we cover all browsers, just in case. I console log canvas width and canvas height, and when I resize we can see the new updated dimensions. That works. I can see that my canvas is now 570 times 735 pixels. Game class will manage the state of all game objects. It will also draw them from a custom method I call, for example, render. We can draw anything on canvas from this ctx variable here. We do it like this: ctx dot built-in fill rectangle method, for example, and that method expects x and y coordinates of the top left corner of the rectangle and its width and height. By default, fill color on canvas is black. If I want to change it, I have to change it before I draw my shape. Fill style is a part of canvas state. When I change the fill color here, everything I draw after will use that same fill, unless I change it again later. I can do the same thing to draw shapes from inside the game class. We are passing ctx to the game here. It's expected here, and it's converted to this.ctx class property. So, to draw shapes from inside render, I just need to use this.ctx instead. Now we have this render method. After the page has loaded and we created an instance of the game class, I take that instance and I call render from it. We are building a responsive game, and one thing we have to understand about canvas is that when we resize canvas, when we set its width and height to different values, it will delete everything that was drawn on canvas. When I resize, my shapes disappear. We don't have animation loop yet to redraw them over and over again, so I can, for example, call render again after I resize, for now. Now the blue rectangle is being deleted and redrawn every time resize method fires. As we said before, fill style is a part of canvas state. Another thing that happens when we resize canvas, all canvas state resets back to defaults. If I comment this out, and instead I declare fill style only on the first page load here, we get the color at first, but when we resize, it gets reset back to the default black color. So every time we resize canvas, we have to redeclare the fill style again, if we want to keep it. Now page load will be black, and resize event will set it to blue. I hope it makes sense. We can leave it like this for now, because we want to animate the shapes around anyway. We animate by drawing a shape, updating its position, deleting it, and redrawing the same shape at the updated position. We do this very fast, 60 times per second, creating an illusion of movement. I will handle this logic inside a custom function I call, for example, animate. For every animation frame, we call render to update and redraw our shapes, and we call built-in request animation frame method, which will call the function we pass to it once. I don't need to say window here. JavaScript knows where to find this built-in method. I call the first loop here, like this. Request animation frame is one-off. It calls the function just once. So I start the loop, we render, and we call the same animate function again. We redraw, and we call it again. As this repeats over and over, we have our animation loop. We are already animating, and my computer is calling render 60 times per second, redrawing the same shape over and over. I can prove it by moving the shape around. For example, we have this.x property, the horizontal x coordinate. We use it here. I can change its value to see it actually works. Every time render runs, we increase this.x by 1. The shape will start moving to the right, in the positive direction, on the horizontal x-axis. We see it like this because all the old animation frames are visible. If we want to see only the current animation frame, we have to delete all canvas paint between every animation frame. Built-in clear rectangle method to delete canvas from coordinates 0, 0 to its width and height. Delete the entire canvas. We have a working animation project. I delete all references to this.x. I create a new file called snake.js. This is where we create our player-controlled as well as computer AI-controlled arena fighters. Maybe I should have called this file player.js to make it more generic, because the following setup can be used for many different games, not just for a snake battle arena game we are building today. I could use JavaScript modules here and import and export them around the codebase as needed, but that requires running this codebase through some kind of a server. I want this project to be very simple, beginner-friendly, and I want it to work by just opening index.html file in any web browser. So I will just include all my script files inside index.html here, like this. I just need to make sure that snake.js comes before main.js if we are doing it like this. I use a console log to check if the file is connected. All good. Here we will create a snake class. Maybe I should have called this just player class. Let me show you how simple it is to create 4 game characters and to give us ability to choose which ones are controlled by user inputs and which ones are controlled by the computer. Each snake will expect a reference pointing to the space in memory where the main game object is stored to allow the snakes to see all the important properties we have on there. Each snake will also expect x and y coordinates where it will start, because I probably want each snake to start from a different corner of the battle arena. Draw method will for now just draw a simple rectangle representing the snake head. Through this.gameReference on line 3, I can access this.ctx property sitting on the main game class. I will use it here, and from there I call built-in fill rectangle method. At first, I just pass it some random x, y, width and height values. This player character will be blue, so this is the snake class. In index.html, I am importing snake.js file before I import main.js, so inside the main game class I can instantiate it. I create a property called this.snake and I set it equal to an instance of the snake class. Constructor expects game and x and y coordinates, so I pass it this, because here in this area, this keyword represents this entire game class. Starting x and y coordinates will be, for example, 0, 0, the top left corner of canvas. Now, from inside the render method, I can take this.snake from line 7 and I call its associated draw method. We defined that method on line 7 inside snake.js. Now we are drawing the snake and the big rectangle we created before. I will make the snake use its actual x and y coordinates here. If I change these, it will move, so I know it works. My player snake will also expect speed x, horizontal speed, and speed y, vertical speed. I convert these arguments into class properties as usual. We will handle player motion inside this update method. Update and draw will run over and over 60 times per second, so for each animation frame, I increase x and y positions by speed x and speed y. I make sure I call the update method. If we give it speed x1 and speed y0, it will move to the right, 1 pixel to the right per animation frame. I can also give it some vertical speed. The ratio between these two speeds will determine the final direction. In the case of this game, it doesn't really matter because we will have a grid-based game. We will only allow the player to move vertically or horizontally, not diagonally. I comment this out and I delete this. This is a grid-based game, so let's draw that grid. To draw a grid, we will cycle over the entire canvas area row by row. Every time we enter a new row, we create cells for that row from left to right. We repeated that process for every row until we covered the entire canvas. We can do that using a nested for loops technique, which is simply a loop inside of another loop. We will need 3 helper properties: cell size, the width and height of a single cell in the grid. My cells will be, for example, 50 times 50 pixels for now. This .columns will define how many columns of these 50 pixel wide cells we can fit next to each other. This .rows will define how many rows of these 50 pixel tall cells we need until we cover the entire game area. We can create a grid using nested for loops, which is simply a loop inside of another loop. This is better explained when we see both of these for loops written down. The outer for loop will handle rows. We keep increasing y row by row until we reach the bottom of canvas. Every time we enter a new row, we map horizontal positions for the cells on that row from left to right. Every time we create a new cell, we will draw a rectangle outlining that cell, so I pass it x from the inner loop, the position of that cell within the row, and I pass it y from the outer loop, defining which row, how far from the top this cell sits. Width and height is defined in the cell size property here on the game class on line 8. We are already drawing that grid, but the cells are on top of each other. Because we are not jumping by the cell size of 50 pixels, we are just jumping by 1 pixel. I have to multiply x times cell size to correctly space them out horizontally and also vertically. So this is how you can create a grid. It's useful for grid-based games as well as for creative coding, for example. There are many grid-based effects. I use these nested for loops, for example, to create complex pixel animations or flow fields. So to recap, to create a grid, we have 2 nested for loops. The outer for loop maps the rows and it will define the vertical y position of each cell. Every time we enter a new row, we map horizontal positions of the cells within that row. X will represent the horizontal coordinate of each cell in the grid. It will represent the column. We start from y0. We enter the inner loop. X is 0. As long as x is less than columns, then the width of the page, we keep increasing it, creating 1 cell next to each other on that row. When we covered all the columns on the first row, we exit the inner loop. We enter the outer loop. Y increases by 1. And again, we map cells on that row. Again, y increases by 1, and we cycle over that next row. We repeat this process over and over until we covered the entire canvas. Maybe I want 20 cells per row. Cell size could be the width of the game area divided by 20. Maybe I want each cell to be 50 times 50 pixels. I will round the value of columns down using math.floor. I do the same for rows. I need to recalculate columns and rows when canvas resizes. I will actually call resize automatically when the game object is created. We know it expects width and height. I can pass it some values here like this. To keep the code clean, I don't want to be declaring that same thing twice. Here, I will just define these properties, and since resize is automatically triggered when the game is created, columns and rows will be calculated here. I can also remove this and this because we are given these properties values inside the resize method. That worked. When the game loads, it will automatically resize itself. I want this game to be fully responsive, and I can't always guarantee that width and height we are resizing to will be divisible by 50 without any remainder, and I don't want to have these edges around like this. Whatever happens, I want the canvas to be always centered and its width and height to be trimmed to increments of the cell size. I want this bit that is outside the grid to be automatically trimmed and cut off. I can do that using modulus, the remainder operator. The remainder operator returns the remainder left over after we divide one operand by another operand. We know I'm setting canvas width to 220 pixels. We know that cell size is 50 pixels. This part of equation gives me 20 because 220 divided by 50 is 4. 4 times 50 is 200, and remainder to 220 is 20. So here I'm setting canvas width to 220 minus 20. We are trimming off that extra 20 pixels to make sure canvas ends where the last cell ends and it doesn't go any further. I will do the same here, trim the part that is outside the grid. 270, remainder 50 is 20. Because the nearest divisible by 50 is 250. 270 minus 20 will set canvas height to 250 pixels. Now we have a centered canvas that is trimmed to 200 times 250 pixels. Cells are 50 times 50, and we have 4 cells horizontally, 200 pixels, and 5 cells vertically, 250 pixels. That adds up. On the first page load, I will resize to the current browser window width and height like this. It will always trim to whatever is outside that last cell, and it will center the canvas after it's been trimmed, so we get a very neat grid-based battle arena on any screen size. You can try and resize your screen to any size you want, and you will see it will work. Not only that, it will also work with any cell size value. Look at this. Cells can be 70 times 70 or 30 times 30. We don't have any half cells at the edges. The grid is always complete, and whatever is outside of the grid gets trimmed. This is a very useful technique for grid-based games. You can use this as a starter code for so many different projects. I will leave the source code from this stage in the resources section below for you to download, in case you want to compare your code to mine or something. You can also save this code for later, and you can reuse it when you are making something like a Frogger game or anything grid-based basically. This is a grid-based game. I want the width and height of the player to be equal to the cell size value. I use that width and height here. This will not work, and the reason is the way I organize my code. We know that snake, when created, needs cell size value from the main game object, but the problem is I'm creating an instance of the snake before I define cell size. This code is executed from top to bottom, so I need to create the snake after all the properties it needs have been defined. The order in which we declare properties and instantiate classes matters. Now the snake moves at 0 pixels horizontally and 1 pixel per frame vertically. Or I can make it move to the right, plus 1 pixel horizontal and 0 vertical. I make it move down. For this game, I don't want to move in 1 pixel steps. I actually want the player snake to be attached to a grid. I want it to jump by cell size as it moves. I multiply this.x and this.y by cell size. Now, this.x basically defines which cell we are in. 0, 1, 2, 3, 4, 5 vertically, and 0, 1, 2, 3, 4, 5 horizontally. Because we are animating 60 frames per second, the player moves too fast. It travels over 60 cells per second, and my game grid right now is only 11 times 19 cells. I want to create a periodic event, and I want to be able to define the interval, how often the entire game updates. Let's say I want the game to update every 500 milliseconds, that is 2 frames per second. In that case, the player would travel from cell to cell every half second, making the grid-based movement more manageable. How do I define FPS of the entire game? I can serve animation frames using setInterval method, but that's not the best way to do it. We are using requestAnimationFrame method to serve our animation frames, and this has an advantage because requestAnimationFrame automatically adjusts to the screen refresh rate. It will not calculate and draw extra frames if our screen cannot display them. It will only serve frames that the screen that is plugged in to the device you are running the code on can actually manage that frame rate. By not drawing those extra frames, we are potentially saving performance. So instead of using built-in setInterval method to control FPS of our game, we will be using requestAnimationFrame and its auto-generated timestamps. For this to work, I first have to delete this render call we put inside the resize method, because if I leave it here, it will break the timestamps. It will make more sense in a minute. I will need one helper property. I will call it, for example, last time. Initially, I will set it to 0. It will hold the value of the timestamp from the previous animation frame. RequestAnimationFrame automatically generates timestamps and it passes them to the function it calls. I can access those values simply by giving it a variable name here. I will call it timestamp, spelled like this. This timestamp is a number of milliseconds that passed since the first requestAnimationFrame in the sequence was called. We will use these timestamps to calculate delta time. Delta time is the difference in milliseconds between the timestamp from this animation loop and the timestamp from the previous animation loop. It will give us a number of milliseconds that passed between the calls of animate, between each request animation frame. Once we calculate delta time, we set last time to the current timestamp so that it can be used as the old timestamp in the next animation loop. Let's console log delta time to see if it worked. My delta time is around 16.6 milliseconds. 1000 divided by 60 is 16.6, so I know my animation is running at a speed of around 60 frames per second. The reason I'm not calling the first animate like this is that it would cause the first delta time to be none, not a number, which could potentially break some other code that depends on that delta time value. So it's better to start the first loop with requestAnimationFrame, like this, to make sure the timestamp gets auto-generated even for the very first animation frame. I pass delta time to render. I make sure it's expected as an argument here. Now, the game object receives delta time, so it is aware of how many milliseconds pass between each animation frame. We can use that value for many different things. For example, I can trigger a repeating periodic event, let's say every 200 milliseconds. To do that, we need 3 helper properties: event timer, event interval, and event update. Event timer will accumulate delta time over and over. Every time it accumulates 200, it will set event update to true. I want event update to be false and to be set to true only every 200 milliseconds. I can put that logic directly inside my render method, but to keep the code cleaner, I will put it inside a separate method. I will call it, for example, handle periodic events. The job of this method is to set event update to true every 200 milliseconds. That's all. It will expect delta time as an argument. Inside, I check if event timer, which starts from 0, is less than event interval of 200. If it is less, keep increasing it by delta time of 16.6 for each animation frame, in my case. Else, meaning that the timer reached 200, we reset event timer back to 0 so that it can count again, and we set event update to true, just for that one animation frame. All other times, event update will be set back to false. It is true just for one animation frame every 200 milliseconds. Now I call handle periodic events from inside render. Delta time will be passed along. I console log event update, and I can see it is switching between true or false. It happens every 200 milliseconds as we defined here on line 12. I only want to update and draw the snake and all other objects in the game every 200 milliseconds, which is around 5 frames per second. We get this weird blinking because I'm deleting canvas too often. I only want to call clear rectangle when we update and redraw. So I call it from here, like this. If I call draw first, it will start from the first cell. So this is one way how you can limit FPS of the entire game, frames per second. We are using timestamps and counting the actual milliseconds, which means that the frame rate will be consistent on all devices, regardless of their screen refresh rate, because we only allow new frame after a specific predefined number of milliseconds passed. I can define the starting speed and the starting cells here on line 15. We will have multiple players. They will use different creature sprite sheets soon, but they can also have different colors. Maybe I want to be able to define each player's color at the point when we create that player. To do that, I make sure it expects color as the 6th argument passed to the class constructor. I will use that color as fill style inside the draw method. Doing it this way, we are able to set the color of the snake when we create it here. Let's try magenta. You can use any color you want here. To make this work, I have to convert the color we are passing as argument into a class property here, so it can be used down here on line 17. Now we are getting magenta. I try orange-red. That works. In this game, we have a snake battle arena where multiple players compete and the longest snake wins. I want to have some user-controlled snakes and some computer-controlled snakes. This is the base snake class. Here we will have all the properties and methods that define the visuals and the behaviors of all snakes. I will extend this class using the extends keyword. This will be a keyboard-controlled snake. It will inherit everything from the parent snake class, but this one will only move if arrow keys on the keyboard are pressed. The extends keyword sets up prototype-based inheritance behind the scenes. This is so-called parent class, also called a superclass. This is so-called child class, also called a subclass. If I create a keyboard snake using this class, it will first take everything I put on this subclass, but if it needs any properties or values that are not defined on here, it will go look for them and it will find them on the snake superclass, on the shared parent class. That way, I can put all the shared logic for all the snake types on the parent class, and the child class will only have a few bits of logic that are specific for keyboard-controlled snakes. If I don't define any constructor here at all, it will just automatically trigger the constructor from line 2. But in this case, I want to add a little bit of extra code into the constructor, so I have to extend it here. We know that constructor will always need these 6 arguments for the snake to work. Now I have to first run all the code inside the parent class constructor. As we said, parent class is also called a superclass. To do this, I need to pass it these 6 arguments along. So this line will execute all the code inside the snake class constructor. And now I can add some extra properties that I want to be only available to keyboard-controlled snakes. In this case, I will give it an event listener for key down event. We already learned that I have to use arrow function here. I will console log the auto-generated event object here. Now, if I save the game and I press keys, nothing will happen. It's because I'm instantiating the parent snake class. I actually want to create an instance of the keyboard-controlled snake. I called that class keyboard1, like this. Now we see the correct snake, and if I select canvas and I start typing, keyboard event object is being generated. This object contains a lot of useful information about the key down event that just happened. The only thing we care about today from here is this key property. As you can see, it gives us the name of the key that was pressed. So if I console log e.key and I type, I get the names of the keys I'm pressing. I make the snake move down. Notice that we set the directions of the snake by these 2 values. 1, 0 is right. 0, 1 is down, because speed x 0, we are not moving horizontally. Speed y is 1, we are moving plus 1 cell in the positive direction on the vertical y-axis, meaning we are moving down. I want the player to move in 4 directions: up, down, left and right, depending on which key is pressed. All snakes, even the computer-controlled ones, will be turning around, so I will put these 4 methods on the shared snake superclass. Turn up, turn down, turn left and turn right. As we change these values, the player will move around the grid in all 4 directions. When we move up, horizontal speed is 0 and vertical speed is -1 cell per animation frame. Moving down is speed x 0, speed y +1. When we move left, we set speed x to -1, -1 cell on the horizontal x-axis, and vertical speed will be 0. And moving right is +1 horizontally and 0 vertically. I want to turn as we press arrow keys on the keyboard. If I console log them, I can see the names of the keys are spelled like this. It's important to know that. Now I can say, if e.key, the key that was pressed, is arrow right, call turn right method we defined on line 32. I reload, I press arrow right, and the player starts moving to the right. That worked. Let's do else if and set all 4 directions: up, down, left and right. Now I can control the player and it will move around the grid in any direction I want. We are building a snake game, so the player is always moving, but this is not a normal boring snake game. This is our custom snake battle arena. We are writing all the code and we fully understand how it works, which means we can set our own rules and we can do whatever we want. I have always found the classic snake game very stressful. One small mistake and if you hit the wall or the body of the snake, it's an instant game over. In this game, I want to create more tactical, strategic experience without the constant pressure of a quick, unexpected fail. Instead of an instant game over, the challenge I want to create is to be quick and efficient at turning around and to be able to navigate the game grid efficiently to get the food faster than the computer-controlled opponents. But I also want this game to work as a kind of a screensaver where you can, if you want, set all 4 snakes to be computer-controlled and you can just watch them eat and grow on their own. Kind of like a snake Pokemon or Tamagotchi game where you can just relax and watch what the AI that you programmed will do. It's really fun, especially after we played with their artificial intelligence and we changed the rules a bit and make them more complicated later. If you want the traditional snake game, you can easily make a few changes to the code and set strict collision rules later. We will cover collision soon enough. The advantage of writing our own custom code is that we fully understand it and it becomes easier to design our own gameplay features and to experiment with them. So let's keep experimenting. Instead of an instant game over, when the snake hits the wall, I want the snake to just stop moving, think for a bit, and then move in a different direction. Eventually, we will make them smart, and they will always try to find the shortest way to get to the food. But let's take it step by step. Right now, the snake can move outside the battle arena, so I want to set up some walls and boundaries. If this.x, the horizontal position of the snake, is less or equal to 0, I want to make sure it can't move any further to the left outside the screen. I will give the snake a property I call moving. Initially, I set it to true. Only when moving is true, we update x and y coordinates of the snake. So now, to stop the snake, I can simply set moving to false. Let's say the starting cells are 5, 0, so it will start here, and I press left arrow key, so the snake will stop moving when it hits the left wall. Now I'm touching the left wall. In the console you can see I'm pressing some arrow keys, but the player will not move anywhere. It is because this condition set moving to false, so no matter what I do, this code block on line 19 will not run until I set moving back to true. I will set moving back to true every time we press a key to turn, like this. Now, when I touch the left side, we set moving to false. I press a key, we set moving to true, but this condition is still valid, so it will immediately set it back to false. We only want to stop the player here if x is less or equal to 0 and $& at the same time only if the player is moving to the left, if its horizontal speed is less than 0. Now when I hit the wall, moving is set to false, but when I press an up arrow key, we set moving back to true, and at the same time we set speed x to 0 and speed y to -1, which means this block will not execute because speed x is no longer less than 0. It is 0, it's not less than 0. So now hitting the wall stops the player from moving any further left, but if I start moving again in another direction, it will unlock the player and we are able to move again. This code block is setting moving to false when we move to the left, but after we stop, if we start moving up or down, by setting moving to true and speed x to 0, we are able to start moving again. Let's do the same thing for the right side of the battle arena. Or operator, and I say if x is more or equal to columns, and if the speed is more than 0, meaning the player is moving to the right, also set moving to false. I test it, and I can see I have to do columns -1 here instead, because rectangles on canvas are drawn from the top left corner towards right bottom. So I turn right, and we get stopped when we hit the right edge. I can move again if I press a different directional arrow key. We covered the left and right boundaries. Let's do the same thing for top and bottom. If this.y is less or equal to 0, and if the player is moving up, yes, that works. And last one, or operator, the vertical position of the player is more than rows -1, and the player is moving down. Also stop it. When I hit the bottom boundary, we stop, but I can unlock the movement again by using an arrow key in a different direction. If you played PC games in late 90s, before we had unlimited connection to the internet, lots of games were played in co-op, with 2 players on the same computer, on the same keyboard. One player would use this part of the keyboard, and another player would use this part. Let's try to implement that. This is the Snake superclass. It contains all the properties and methods shared among all types of snakes in our game. We are extending it into Keyboard 1 subclass. This is a snake controlled by arrow keys on the keyboard. I'll extend it into another subclass. I will call it, for example, Keyboard 2. It will use 2 lowercase built-in JavaScript method. This will make sure that this if statement will be true if we press lowercase as well as uppercase W. So W is turn up, I copy these. S is turn down, A is left, and D is right. Okay, that was easy. Now I can choose if I want the player to be controlled by arrow keys or by WSAD, by instantiating one of these 2 subclasses. Now I can play on the left side of the keyboard or on the right side of the keyboard if I want. I rename this.snake to this.player1. Maybe I want player 1 to be controlled by the arrows and player 2 will be controlled by WSAD. Now that I have more than one player, I can also create an array where I put all the game objects. Instead of drawing and updating each snake separately, I can take this.gameObjects and for each player object in that array, I call its draw and update methods, like this. I want player 1 to start from cell 00. Player 2 will have a different color. Player 1 is arrow controlled. I'm console-logging the keys here. Player 2 is controlled by WSAD. Now you have a very simple blueprint for a local 2-player game. It all works, but there are many ways in which we can improve it. I delete the console logs. Let's say I want player 1 to move to the left, so speed x1, speed y0. And I want player 2 to start from the top right corner of the battle arena. I need to use columns here, but the value of that property has not yet been set at this point. We are setting those inside the resize method, and then we are automatically calling resize when the game loads. I will initialize the player after we set rows and columns. Again, I want to avoid code repetition, so I will only define the properties up here. And I give them values down here. Now player 2 can see columns and it knows where on the screen it should start. Here is the snake superclass. We are extending it into keyboard1 subclass, keyboard2 subclass, and I will extend it again, this time into a custom subclass I call, for example, computer AI. Computer AI extends snake. It will inherit and have access to all the methods and properties on the parent class. Again, it will expect these 6 arguments that all the snakes need. We know that the first we have to call superclass constructor to execute all the code in here. Computer AI snake subclass will also get automatically access to all these methods because we are using the extends keyword here. And I will add some extra code to the constructor, but before that I will extend the update method from line 13. When extending a superclass constructor, we use this syntax. Extending a regular method like this update is done using a slightly different syntax. This line will call this method first to handle boundaries and motion. And then I can add a little bit of extra code that is unique only to computer AI snake. Keyboard controlled snakes will not have access to this. We will write our own AI. First a very simple version and then more advanced version where the snakes can see the food and they will try to move towards it. The hungriest snake wins the game. The first simplest version of the AI will be blind. It will not see the food or the other snakes. It will just have a timer and it will turn in a random direction every time the interval value is reached. It is super simple, but when you see it in motion, even this simple thing gives a lot of life to our game characters, and you would be surprised how many games use just this simple version of artificial intelligence to make the game worlds feel more alive. I want to create a counter. Every time the counter runs out, make computer-controlled snake turn in a different random direction. We already used a similar technique for counting milliseconds. This time we will count steps. Let's say every time the snake travels over 5 cells, make it turn. Turn timer will count from 0 to 5 over and over. Same as we are setting event update to true every 200 milliseconds to update and redraw the game. Every time this event interval value is reached, event interval is 200 milliseconds, so we know update method on the snakes is called in that interval. 5 times 200, snakes will turn approximately every 1 second. We will randomize this a bit more soon. So keep in mind that this update method runs at around 5 frames per second, every 200 milliseconds. Also keep in mind that every time update runs, snake will move to another cell in the grid. That will also happen 5 times per second. If turn timer is less than turn interval, increase turn timer by 1. When turn timer reaches the interval, the else statement will run. We set timer back to 0 so that it can count again, and we call a custom turn method. Turn method will have only one job, to pick a random direction out of these 4 and to make the player move in that direction. I define that method on here. It will only be accessible to computer AI snakes. The new random direction we choose will not be completely random. It will consider the current direction of the player and then it will decide. If the player is not moving vertically at the moment, it means it is moving horizontally, so we want the player to turn up or down. I can do an else if statement here, but since we are using JavaScript, I can use a simplified syntax. This is so-called ternary operator. I will use it here as a simple one-line if-else statement. If math.random is less than 0.5, math.random called on its own like this will give us a random value between 0 and 1, so it will be less than 0.5 in roughly 50% of the cases. So when turn method is triggered, if the player is moving horizontally, in 50% of the cases, make it turn up. In the other 50% of the cases, make it turn down. Ternary operator used as a simple one-line if-else statement. Expression to evaluate, if true, question mark, do this, else, colon, do that. Else if the horizontal speed is 0, we know that the player is not moving horizontally right now. We do the same random else if and we turn left. I forgot the brackets here. Or we turn right. So update method runs every 200 milliseconds. Every time it runs, the player moves to a different cell in the grid. Once the player moved over 5 cells, make it turn in a different direction. So now we have 3 types of players: keyboard 1 controlled, keyboard 2 controlled, and computer AI controlled. I can choose the controls by instantiating one of these subclasses. I create player 3 and it will be controlled by the very simple computer AI we just wrote. It will start from bottom right corner and I want it to start moving to the left. And we give it a yellow color, for example. Now I add player 3 to game objects to animate it. Player 4 will also be computer AI controlled. It will start from the bottom left corner of the battle arena and initially it will be moving up. I give it a dark blue color, for example. I add it to game objects array to animate it. We know that inside render we are cycling over all player objects inside game objects array and we are calling draw and update methods on them. Player 1 and player 2 are keyboard controlled, so they will stop if I don't press any keys on the keyboard. But player 3 and 4 are moving around, being controlled by the simple logic we just wrote. I can make them turn every 2 cells. Or how about I set the turn interval to a random range. I wrap it in math.floor to round it down to the nearest lower integer. Yes. And actually, I can even randomize that interval again every time the player turns, creating a random, unpredictable movement. When the computer-controlled player hits the edge, they stop moving, and sometimes they don't turn immediately. They need to wait until the turn timer counts enough steps, and then they can turn again. I actually like that, because it looks like they have to stop and think for a moment before they decide where they will move next. It's interesting how my brain assumes they are thinking where to go next when I watch them, even though I know that's not what's happening. When you know a few of these tricks, you can use a relatively simple code to create an illusion of a living, thinking NPC character in your game. We are doing the simplest version of artificial intelligence I could think of. I want us to really understand, and I wanted to show you that even something as straightforward and rudimentary like the AI logic we just wrote can create a cool result. I set all 4 players to computer AI. When I watch them, my brain comes up with all kinds of observations. Sometimes they look like they chase each other. They try to avoid each other for a second and then they decide to ignore each other. We know that they aren't doing any of that right now. They just walk for a random number of steps and then they turn in a random direction. But we already have a little bit of something here. We will improve this artificial intelligence soon and we will learn how to make them search for food and eat it. Now I can take any of my 4-player characters and I can assign them keyboard controls or computer AI controls. This is a nice base for many different games. If you have a game designer imagination, you can see a lot of potential in this code base, in what we built so far. And you can take this in hundreds of different directions and create hundreds of different games from this. We learned a lot. You want some more? Let's go! If you need my help while coding along, there is a source code from this stage of the project in the resources section below. Comparing your code to mine can help you with debugging. Click the like if you are getting some value today. I create a new JavaScript file I call food.js. Class food will handle everything the snakes will eat. Constructor will expect game as an argument, so we can access all the useful properties and methods we put on the main game class. Each food object will have x and y coordinates, where in the game grid it will sit. It will have a reset method. Whenever the food gets eaten, it will reset somewhere else in the grid. At some random horizontal x coordinate, I need to do math.floor to remove the decimal points. We don't have column 1.5, for example. And this.y will be a random row, somewhere in the game grid as well. I make sure I include this new JavaScript file here inside index.html. All the objects in the game will have draw and update methods. I need to convert game into this.game here as usual. Now I can take this.game.ctx, accessed through this, coming from here, and from there I can call built-in fill rectangle method. I will draw a rectangle representing the food item. It needs x, y, width and height. The food will be the same width and height as the size of a single cell in the grid. I will give it a white color for now to distinguish the food from the snakes. When we create the food, we will immediately call reset here to give x and y some values. Here we defined our players. I will declare player 3 and 4 as properties here as well to keep it organized. I will also create a new property. I give this.food property a value inside the resize method. This method will basically restart the entire game every time the game grid resizes. This should normally not happen mid-game because we assume that players will access the game on a certain device that has a set screen size, and that screen size should not be changing mid-game anyway. I set this.food to an instance of the new food class we just created. It expects game as an argument, so I pass it this, representing this entire game class. I add food inside game objects, which will automatically animate it. For this to work, every object inside game objects array needs to have draw and update methods, otherwise we will get an error. That's why I gave food update method here, even though it's still empty now. We will use it to give the food items some animations later. If I save my project, we can see the food now as a white square. But I can see that it doesn't snap to the game grid. The reason is that I'm drawing it at this.x and this.y, which define the position of the cell in the grid, but not the actual coordinates. The actual coordinates are the position times cell size. Now, every time I refresh the game, food will sit in some random location in the grid. In a grid-based game like this, it's extremely easy to check for collision. We don't need any math here, not even the simple collision detection formula between two rectangles is needed. Because if you know that all game objects always snap to the grid, we can simply check if they sit in the same cell within the grid. If two objects occupy the same cell in the grid, we know that they collide. I will create a reusable utility method I call check collision. We can use it all over the code base for a collision between two objects in our game, as long as those objects are attached to the grid, the same way the food items and player snakes are. We take object A and object B, so for example head of my player snake and the food, and we directly return true or false, like this. If object A is in the same column as object B, if their X properties match, and at the same time object A is sitting on the same row in the grid as object B, if their vertical positions are the same, we know that object A and object B occupy the same cell in the grid. This.x and this.y don't represent coordinates in this case, they represent columns and rows in our grid, so it's easy to compare them like that. Only if both of these conditions are true, the objects collide. They are sitting in the same cell in the grid. If at least one of them is false, it means they sit on a different row or in a different column. Now I can use this new method to make the snakes eat the food. I will do it inside the update method on snake class, even though I could have done it also inside the update method on food class if I wanted to. We know that check collision directly returns true or false. It expects object A and object B as arguments. So I pass it this, representing the position of the snake in the grid, and I pass it this.game.food, which also has X and Y coordinates, representing the position of the food in the grid. If this snake and food collide, we reset the food, which will move it to a different random position in the grid. I take control of one of the snakes by giving it keyboard 1 controls. I'm controlling the orange-red player. If I move over the food, snake eats the food and the food resets to a different position. Each snake will have its own this.score property. Initially I set it to 0. When a snake collides with food, I increase its score by 1. We can display that score in two ways, drawing it on canvas or creating a scoreboard with CSS. I will draw it on canvas inside a custom method I call drawStatusText, at least for now. Built-in canvas fill text method will take the text we want to draw and x and y coordinates where we want to draw it. The text I want to draw will be a static p1 space plus dynamic variable value of player1.score. X and y could be the cell size, for example. We will position the text better later. Keep in mind that these x and y coordinates define an anchor point in relation to which the text will be drawn. Where the text sits in relation to that anchor point is defined by two HTML canvas properties: text align horizontally and text baseline vertically. We will do that in a minute. I call draw status text from inside render. I will draw that text after I draw my game object, which will put the text in front of them on top. We are drawing the text here. It's very small. We know that we have to redeclare everything related to canvas state every time we change canvas size, because at that point everything resets back to default. So I set canvas font here, 50 pixels impact. I want the anchor point of the text, which we set to cell size, so this point. I want that anchor point to define the top left corner of the text, so I need text align to be set to left, which it is by default. And I need text baseline to be set to top, which will make the text hang down from the anchor point we defined by passing x and y coordinates to fill text method earlier. I make the font smaller. Let's add a colon. I copy this line and we will display player 2 score. Vertical coordinate of the anchor point will be cell size times 2 to position this line under player 1. I will do the same to display player 3 score. Cell size times 3. And player 4, cell size times 4. We will make this look better, but for now I have a simple scoreboard and I can see that every time any player collides with the food, their score increases by 1. I can control the orange-red player and collect the food. I can see on the scoreboard that I get a point every time I eat something. It will get much more challenging to collect the food when we improve the computer AI and we make the other snakes very, very hungry. Keep watching if you want to learn how to do that. I call our players snakes, but right now they are represented by a single square that moves around the game area. Let's give them more body segments. Let's make them longer every time they feed. I give snakes this.length property. This will define the current number of segments that make up each snake's body. This.segments will be an array. It will hold a simple object for each body segment. That segment object will just store x and y coordinate of each body segment in the grid. If the snake is moving, we will be adding more segments. Built-in JavaScript unshift method adds an element we pass to it to the beginning of an array. The snake is moving. Every time it moves to a new cell in the grid, we will add a very simple segment object inside this.segments array. For now, this segment object will have only x and y properties, and those coordinates in the grid will be equal to wherever in the grid the first segment, the head of the snake, sits at this point when the new segment is created. Inside draw method, instead of drawing just the head, I take this segments array, and for each segment object in that array, we draw a rectangle. Now I'm drawing all of them on top of each other. They move around with the snake. Instead, I want to use x and y coordinates of the segment itself, because we know each segment has different x and y as the snake moves around and new segments get created. I use segment x here and segment y. This will give us endlessly growing snake bodies. This.length property we defined here on line 13 will define the number of segments that make up the snake body. So down here, every time the snake moves to a new cell in the grid, we create a new segment in that cell by pushing a new segment object to the beginning of this.segments array. And if the length of the segments array is more than this.length property, we use built-in pop method that will remove the last element from an array. So now the snakes grow until they have 5 segments. Then, as they move around, they add a new segment to the beginning and they remove the last segment. And this is one of 2 ways how we can create this crawling snake effect. The other one would be to shift the indexes and keep the same segment objects. If I want to give the snake heads different color, I can target the first segment in this .segments array, the element with an index of 0. When we use for each method, it auto-generates index for us. All I have to do to use it is to assign it a variable name here. I will call it I. If index is 0, the first element in the array, that will be the head with gold fill style. All the other segments will keep the other snake color we predefined. Now we can see their heads. Let's say each snake starts with just 2 body segments. We have these small snake babies. I can say every time snake eats food, increase its length by 1. I control player 1, the orange-red snake. Every time my snake eats the food, the white square, I get 1 additional segment. So we have snakes crawling around, and when they eat, they get longer. Nice work! In this project, the snakes can move through each other's bodies, and they can also move through their own body, but I don't want them to be able just to turn back on a spot and walk through their own head. If they want to turn back, they have to go around like this. To prevent them from turning back on a spot, I will only allow vertical movement when they are moving horizontally, and I will only allow horizontal movement when they are moving vertically. They can only turn up if vertical speed is 0, meaning that the snake is facing left or right. Otherwise, it will not turn, because if its speed y is negative, it's already moving up, so there's no need to turn up again. And if speed y is positive, the snake is moving down, so we want to prevent it from turning up at that point. Same for turn down. If the snake is moving up or down, we don't do anything. We only turn down if the snake is not moving vertically, up or down, at the moment when this code runs. We only turn left if the snake's horizontal speed is 0, so we know it's not moving left or right. And we only turn right when horizontal speed is 0. This will solve the problem for computer-controlled players, and in most cases for the user-controlled snakes as well. But we are running the game at only 5 frames per second, and if I mash the keys really fast and I press multiple keys very quickly, in that short period of time between animation frames, it can actually mess the directions up and the snake can still walk through its own head. To prevent that, I can say only allow the player to make a turn once per animation frame, then disable any turning until the next animation frame. Preventing the player from changing direction multiple times per animation frame will solve this issue. I will create a simple flag. I will call it ready to turn. Initially, I set it to true. Every time we serve the next animation frame, we set it back to true. When we turn in any direction, we set it to false. And we only allow turn in if ready to turn is true. So we turn, we set ready to turn to false, and until the next animation frame runs, we can't turn again. Now, even if I press keys very fast, it shouldn't be able to turn back on a spot and walk through its own head. Let's create a control panel, a div with an ID of controls here. This will be a wrapper for the entire game menu. Inside, I create another div that will serve as a wrapper for the 3 main buttons. Button with an ID of start button. It will say start here. The second one will have an ID of debug button. The third one will be a full screen button. In style CSS, I give controls div position absolute to bring it in front of canvas, which is also positioned absolutely. I give it some border, top 5 pixels, left 50%. And I offset it back by a half of its width horizontally to center it exactly in the middle of the page. Padding 10 pixels. Background will be a black color with some opacity. I remove the border. Buttons div, the wrapper for all 3 buttons, will have a set width of 260 pixels. Display flex to align them better, with justify content set to space between. I'm not going to explain CSS flexbox in this class. I think if you understand the JavaScript code we are using in this project, you are not a complete beginner and CSS is easy for you. The main focus of this class is JavaScript and game development, and that's what I'm explaining in depth. Each button will be 65 pixels wide, black background, and white text. I create another div on the same level as buttons. I give it an ID of score screen. We are drawing score on canvas already, but I want to show you a different way how to do this, and we will take this score screen to the next level. I will separate it into 2 columns, left and right. The left column will display the current score and whatever custom name we give to player 1. I give it an ID of scoreboard 1. The text is black, I set it to white here. Left column will also display the custom name and score points of player 2. Right column will display player 3 and player 4. There are many ways I can turn this into a 2-column layout. Let's give it some padding first. Display flex will do it, for example. Let's give both left and right columns some border so we better see what's happening. I set justify content to space between this time, which will separate them like this. I need to give it some column gap because if this text here is longer, I don't want it to touch the other column. We always want some space between them. I can put the logic to control the menus and buttons somewhere on the main game class, but to keep the code cleaner, let's create a separate user interface class, and I will write that logic there. As always, we will need access to the main game class and all its methods and properties. We will do a few cool things here. First, let's handle this scoreboard we created up here. The game will always have 4 players, even if all 4 of them are controlled by the computer AI. I create references to all 4 player scoreboards here. I give UI class an update method. Scoreboard 1 will have a dynamic inner text value. For now, player name will be hard-coded P1 : space plus a dynamic player 1 score variable. Okay, before we do the other players, let's actually use this class to see if it works. I create an instance of game UI here on the main game class. Be careful about the spelling. I decided to spell it like this. Capital and lowercase letters matter in JavaScript, so we have to pay attention to them. I pass it this keyword representing the game class itself. UI class is not defined because I also have to actually include this new UI.js JavaScript file in index.html like this. Now I can take this.gameUI and inside render for every animation frame, I call its update method we just wrote. Now we can see it actually changed the inner text of player 1 scoreboard. I can delete drawStatusText method here and also all the code in here. Let's also handle scoreboard 2, P2 plus player 2 score. Scoreboard 3 is P3 plus player 3 score. And I do the same for player 4. We can see it all works. Right now, I'm hard-coding player names as P1, P2, P3, and P4, but we can also make them dynamic. Let's start by adding another argument to snake class constructor here. I call it name, and I convert it into a class property. I also have to pass it through all the subclasses like this, because we never instantiate the parent snake class directly. We are always instantiating one of the 3 subclasses. We define players here and we instantiate them here for now. We know that they expect an additional argument. I can put, for example, Frank here, player 2, computer AI, and computer AI. Now that each player snake has a name, I can actually display it here. Player 1 name plus colon space plus player 1 score. I do the same for player 2. You can see it works nicely here. Let's do the same for player 3, which I named computer AI for now. And player 4 is also named computer AI. I make the snakes longer. I can delete this to remove the borders. I can also set a different font here, maybe 15 pixels consolas, which will work automatically on my Windows computer. I don't have to import it from anywhere. You can use any font you want here. I like this one because it looks a little bit retro. I need to change it on buttons here as well. Notice that as the snakes eat the food, their score increases and it is correctly displayed on our scoreboard. The main controls panel will have a third main block. We have buttons here, score screens here, and the third part will be the most fun. I will call it game menu, for example. It will allow us to rename our players, assign them different control schemes, and choose the graphics, what snake character they will be. I'm giving you a variety of different snakes with this project, from sausage dogs to crawling carnivorous plant snakes. This block will also contain some status messages. Those messages will change if we win and lose the game and so on. But first, let's deal with the player choices. In this block, we will handle all the choices that relate to player 1. We will do the same for players 2, 3, and 4. I will separate them by a block of text. I call it player label. Again, I create a label to separate each individual player area. First, controls. From the first drop-down, we can choose if player 1 will be controlled by the user or by computer AI. Select element, ID player 1 controls, and the name will be the same as well, like this. Each option we put in here will appear as one of the options in the drop-down. First one can be keyboard arrows, value arrows like this. The second option for player 1 is computer AI, value AI, which will be important soon. We can see the drop-down here. Player 2 controls will be, for example, keyboard WSAD, value WSAD, or computer AI. I need to close the select tag. I copy this block again for player 3. I adjust these. For now, let's leave only computer AI option. And I copy this and adjust these values for player 4. Okay, this is a good start. We gave each player a drop-down to choose its controls. It's probably a good idea to give it some styling. Div with an ID of player choice. I give it some padding to separate it a little bit. 10 pixels top bottom and 5 pixels left right is good. Player labels will have a bigger font size, maybe 20 pixels, and some margin top to create some space in between them. Nice. Let's create another set of inputs for player names. Label for player name will say name. Input with the type of text and ID will be player 1 name. I want them to be on separate lines, so I will wrap them inside a div. Div is a block element, which means it doesn't allow anything to sit next to it by default. This will automatically push name to its own row. I wrap this in a div. Actually, only one of them needs to be in a div, I think. Yes, this still works. I copy this block and I do the same thing for player 2 name. Player 3 input will be here. And I also do player 4 name here. This should be player 3 name. My goal is that when we write a custom name here, it will appear down here on the scoreboard, and we will do that soon. Before we finish player inputs, let's create a background. I want the first 2 rows of the grid to be reserved for environmental art. This will also allow us to have the main part of the scoreboard placed up here, permanently visible, without the snake scrolling behind it. We can then use these top 2 rows of the grid for other things as well. It will be a space where we can put things that we don't want to mix with the actual gameplay area. This is a responsive game, so we don't know if the grid will have just 10 columns on some small device or if it has 50 columns on a large wide screen. We need a background that will work for all these different screen sizes. I created horizontally tileable repeating texture for this. We will handle it in this new background class I'm creating here. It will have X and Y coordinates, the width of a single tile. In that repeatable background will be, let's say, 8 cells in the game grid. We know that cell size is set to 50 pixels, so the width is 8 times 50, 400 pixels. Height of the background tile will be the size of a single cell times a helper top margin value. Let's say I want top margin to be the top 2 cells in the game grid. And actually, while top margin is 2, to make sure player snakes can move up here, but not here, we will do that in a minute. The image itself will overlap a little bit because I gave it some shadows. So the background image will actually extend over 3 rows of the game grid. Top margin plus 1. I give it a custom draw method. Inside, I call built-in draw image method. We need to include that image in the project. I will include all my art assets down here inside index.html. You can download everything you need in the resources section below if you're following along. In my project, I create a subfolder called assets, and in there another subfolder called images. I place the background image in there. I called it forest margin repeat. IMG element with source pointing to the location where I placed my image. And importantly, I need to give it some ID so we can easily target it with JavaScript. I will wrap all my art assets in a div with a class of assets. The image itself shows here. I want to hide it, so I give everything inside assets div display none. I also give my body element a black background. I included this new background.js file here. Now I can create this.image property pointing to that new image we just included using its ID, forest_margin_repeat. Built-in Canvas draw image method is very important to understand. The simplest version of draw image takes only 3 arguments: the image we want to draw and X and Y coordinates where to draw it. I want to call this draw method we have here. On the main game class, I create a property for my background. I will only assign it an instance of player class after we calculate it with height, rows, and columns. I pass it this keyword as always, referencing this entire game class. Inside render, I can now take this background and I call its draw method. Just for a moment, I will set controls to display none so we can see the background. You can see it matches the grid 8 cells horizontally and 3 cells vertically, 8 columns and 3 rows. I need a helper property that will tell me how many times I need to repeat the background to cover the width of the game. The background image I'm giving you is tileable and is repeatable, so if you place them next to each other, they will connect seamlessly. Inside the draw method, I create a for loop. It will run as many times as needed to cover the width. Now I'm drawing all of them on top of each other. Draw image method is drawing the image at its original size. It only fits the grid because I created the actual image in that exact size. Draw image method can take optional fourth and fifth arguments for width and height, in case we need to resize our images. The image will be stretched or squeezed to fit in the area we define here. To space them out, I have to adjust the horizontal X position of the image. I can move it around like this. As the for loop runs and index increases, I want each image to be drawn at the index times width. So the first image will be at 0 times width, which is x coordinate 0. The second image will start from 1 times width, and so on. I can give this class a resize method to recalculate repeats whenever canvas changes size, but we are actually creating a new instance of background class inside resize method on the main game class, so this will get recalculated anyway every time the screen changes size. When I change my screen size, you can see the background always covers the width of the browser window. It covers it from left to right. I can check if I'm not drawing an extra one unnecessarily. Right, if I do -1, we get an empty space, so we actually have to draw image for every index in the for loop. Good. The top 2 rows of the game grid are now reserved for the background artwork, for game menus, for buttons, and some status text. I don't want the snakes to be able to move into that area. Player 1 starts from the top left corner, cell 0, 0. I will make it start from 0 top margin, from here. The starting vertical cell of player 2 will also be top margin. Great. Now I need to make sure that the food only resets in the playable game area, so I have to exclude the 2 top rows. I do it by restricting the range to rows -2, and then I move that entire range to start from the cell 2, like this. In the boundaries section, I want the snakes to stop when they hit the top margin. I control the orange-red snake. If I try to move up, I hit the boundary here. Now we have a wall here. The snakes can't move into this area. The background image itself covers 3 rows. There is this overlapping row of cells to make the background blend in with the game world. I can display the controls panel again. The game will have 2 states. The best way to implement them would be with the state design pattern, I think. But since we have only 2 states, the simplest way to implement them would be to have a game over variable. When game over is true, the game is paused and we can see a full menu screen. When game over is false, the game is active and playable. I only want to update and draw game objects when game over is false. Exclamation mark means false. Here we have a resize method. Its job is to set the size of the game grid and so on. I will also create a separate start method. This method will handle everything that needs to happen when the game starts and restarts. I will leave background inside the resize method, because when we resize, we need to recalculate how many repeating background tiles we need to cover the new updated width. If we just restarted the game and nothing resized, we can leave the background alone, but we need to reset positions of all 4 player snakes and we need to reset the food. When we start or restart the game, game over will be set to false. I get an error. Update method on my UI class can't find player name when it needs it. The reason is I'm calling update UI. That's not needed now. It's not supposed to be outside this code block. I put this line into this code block. It only needs to update player scores if the game is actually running. So this is what we see when the application starts. When I click the start button, I want the game to start. I will handle the buttons here. We created the start button up here. I create a property representing the start button. I apply an event listener to the start button. We will listen for a click event. Again, I have to use arrow functions here for the callback to keep this keyword pointing to the UI class. That way, I can access this.game property and I can call its start method from here. We defined that method here on line 44. When I click the start button, game over is set to false, which means that render method starts animating the game. That worked. I will need a helper method that will run when win or lose condition is met. I will call it trigger game over. Inside, I set game over to true. Win condition will be when the first snake eats enough food. If this.score, the score of this particular snake, is more or equal to winning score, we call trigger game over method. I actually called it game UI here, so I have to do it like this. For testing purposes, I will set winning score to something low, like 2 for example. I click the start button, I control the orange-red snake, I eat one food, my score is 1. When I eat another, the game freezes because I reached the win condition and trigger game over method runs. That method, as we know, will set game over to true, which will prevent render method from running because of the condition we introduced earlier. The game will have 2 states, game over true and game over false. I want to display a different UI in each state. Gameplay UI will set up the UI display when we are playing. Game over UI will create user interface for times when we are in the game over state and the game is paused. I want this block, buttons, and this block, score screen, to be always visible. The third block, game menu, will only be visible if game over is true, when the game is paused. I want game menu to be set to display none when game over is false, when we are playing the game. It will only appear when the game is paused. I create a reference here pointing towards the game menu block. This is what will happen when we play, when game over is false. I want the game menu to be hidden, so I access its style property and I give it display none. When game over is true, game over UI will be active. Here we will set game menu display to block. When trigger game over method runs, we will display game over UI. Gameplay UI will be displayed when we start or restart the game by clicking this button. Now we can see game over UI. When I start the game, the big block hides and we see only the gameplay UI. When I click start again, the game immediately restarts. First of all, when we are playing, I want the start button text to be restart. When we are in game over state, the text on the button will say start. We trigger game over when one of the snakes wins the game. I also want to be able to click the restart button again, and if the game is active, it will send us back to the start menu. So here, when the start method runs, if game over is false, if this method runs after the game already started, we will call trigger game over. Else, meaning the game is in game over state, only then start the game. Like this. Okay, great. We start, I can play, I click restart and it gives us the game menu again. I can start the game and return back to the game menu by clicking the same button now. Maybe we can also have an image or some kind of overlay we want to display when we are in the game over state. I will call it game over screen. I target it with CSS and let's start by giving it blue background. Position absolute to bring it forward and I need to give it some width and height. Yes, there it is. So let's do width 100% and height 100%. We will control it from here, this.game over screen. Gameplay UI will hide it by setting its display to none. Game Over UI will show it by giving it display block. So now, when I start and restart the game, we can hide and show it. When I restart the game, we can see the game objects before they reset, because we are running update at a limited frame rate. So I make sure I delete all the old paint on entire canvas by using built-in canvas clear rectangle method. Now, starting and restarting the game looks cleaner. I'm also giving you a game over screen image. You can download it in the resources section below. I put it into my project folder, inside assets/images, and I can set it as game over screen background. It repeats down here. I will set background repeat to no repeat, and I will set background size to cover to make sure the background always fully covers the entire canvas, regardless of the current screen size. Yes, that works. We added a lot of new functionality. These techniques are very useful if you want to create your own unique game worlds. I want the snakes to be able to walk through each other, and I also want them to be able to walk through their own bodies, but I don't want them to be able to turn back on a spot and to walk directly through their own head. That's why we introduced some rules and limitations that determine when the snake can and cannot turn in specific directions. I also have a rule that when the snake hits the wall, they don't get a game over. They simply stop moving and they can turn and move in a different direction whenever they are ready. This implementation causes a problem that allows the snake to walk through its own head under specific circumstances. Look at this. I'm controlling the orange-red snake. I move down along the left edge of the game area and I press the left arrow key. Because there is a wall there, the snake just stops. Visually it's facing down, but its directional values in speed X and speed Y are set to left basically, even though it looks like it's facing down. In reality, its internal speeds point to the left. This check actually passes and I can now turn up and pass through my own head, which is something we want to prevent. When the snakes move along the wall, they turn into the wall and stop. Then they are able to turn on a spot and move through their own head. I want to prevent that. I will do that by not allowing the snakes to turn into the wall and stop like this. First of all, this is code repetition. I remove it here and I will set it up here. Let's make them turn more often. Let's say every time they travel over 1 to 9 cells in the grid randomly. Back to the first problem. I'm controlling the orange-red snake with my keyboard. I move along the top edge. I turn up, but there is a boundary, so the snake just stops. The snake is facing right visually, but because I pressed the up arrow key, its internal state actually looks like it's facing up. That means this check passes, and now I can go from facing right directly into facing left, passing through my own head. We want to prevent that. While the snakes are moving along the edges, I will not allow them to turn into the wall and to stop like this. This should solve the problem. Only allow the snake to turn up if it's not already inside the topmost row in the game grid. Now, when I move along the top edge, I press up arrow key, but the snake will not turn, because there is nowhere further up to go. Otherwise, the snake can still move around and stop and resume movement freely, same as before. It just can't pass through its own head anymore. I do the same thing for the bottom boundary. If the snake is moving alongside the bottom row, don't allow it to turn down, because there is nowhere further down to turn. So we covered the top and the bottom boundaries. I do the same thing for the left boundary. Only allow the snake to turn left if its head is not already in the leftmost column, if this.x is more than 0. And for the right boundary, only allow the snake to turn right if its head is not touching the right edge of the game area. Now we fixed it. We have these drop-downs for controls for each player. We created HTML markup for them here. I gave each drop-down an ID here. I need to get a reference to these drop-downs with JavaScript. Each drop-down will be represented by a custom property on UI class. Player1 controls is equal to document.getElementById, and I pass it the ID I gave it. I'm keeping the property names the same as IDs to keep this organized. I create references for all 4 player controls. We define the properties for each player here, but we only assign them to instances of snake subclasses here inside the start method. We can see that player 1 is controlled by the keyboard. The other 3 players are controlled by computer AI. I create a custom method I call, for example, initPlayer1. In there, we will handle the setup for player 1. Remember that this will run when we press the start button. So at the point when we press the start button, we will have a look at the property representing player 1 controls drop-down, and we will check what value it has. If the value is arrows, let's follow the code. This.gameUI is coming from line 26. Player 1 controls property is here on line 19, and it points towards the actual HTML element with that ID. The ID is here, and the value will depend on what we select from the drop-down. For now, I gave it only 2 options. The keyboard arrows, so the right side of the keyboard controls, and computer AI. So this value is arrows. Back here I say, if the value in the drop-down is arrows, create an instance of keyboard1 subclass, a keyboard-controlled snake. The other option is AI, but since there are only these 2 options, I can just say else, create an instance of computer AI, like this. Some of you can probably think of a better way how I could have done this. State design pattern would work well to determine controls. I might have a look at this later in the class as we progress with the project. I structured this codebase to be as beginner-friendly as possible because I want everyone to be able to follow. And state design pattern introduces a lot of complexity that I'm trying to avoid at this stage. Give me your feedback if you want. I read all the comments. I call initPlayer1 here. So when we click the start button, this method will check the value of controls drop-down, and based on that, it will decide if player 1 will be a keyboard-controlled or AI-controlled snake. If I select computer AI here and I started the game, player 1 is controlled by the computer. If I select keyboard arrows, I can now control the movement myself. That worked. I copy this code block, initialize player 2. If player 2 controls value is, and here the options are WSAD, the left side of the keyboard, or computer AI. If the value is WSAD, I copy this block here and here. Here it will be keyboard 2. Keyboard 1 subclass has arrow controls, keyboard 2 subclass has WSAD controls. Now I can call initPlayer2 here. I tested by setting all 4 players to be computer AI. That worked. Now I try to set player 2 as keyboard WSAD controls. Now I'm controlling the magenta snake myself. Great. initPlayer3, this one will have only computer AI option for now, but we could easily add mouse controls or maybe a gamepad if we want. For now, player 3 and player 4 will always be computer AI controlled. If you want to give them keyboard controls or something else, you can follow the same logic I just used for players 1 and 2. I call initPlayer3 and initPlayer4. We connected the control drop-downs, so now when we start the game, these methods will check values of those drop-downs and they will assign controls to each player accordingly. I also created the name input field for each player. Let's connect that. First of all, I give them some default values. P1, P2, P3, and P4. Now I want to have access to these input elements with JavaScript. I create a property for each player. I gave them IDs here. I create a property for each player name input field. When I create each player here, we pass the name as the 7th argument to the class constructor. I create a variable I call name, and that variable will take its value from player1 name input field. I pass it to the constructor here and here. Now, when I press start, player1 should change to P1. Yes, that worked. Restart. I will call player1 Hungry Snake, for example. That worked. I can make the score screen a little bit wider. Maybe 300 pixels. Now the buttons are not centered. I can just give them position relative and margin 0 auto to center them horizontally within the controls container. Let's connect the name inputs for the other players. Player 2 name value, and I pass the name here and here. I type something in here. That works. Player 3 name dot value, and I pass the name. Player 4 name value, and I pass the name. Constant variables are block scoped, which means they exist only within the code block. For example, this one only exists in the area between these two brackets. For that reason, I can create multiple constant variables with the same name and it will work. They are each in a different scope. They don't interfere with each other. You can get more creative with the names, or the names could be also connected to different creatures we will have in the game soon. I know it breaks to another line if the name is too long. I could restrict the character limit in these fields, or I could adjust my CSS. I will be using mostly shorter names, so it's fine for now. We have a full screen button here. Let's make that work. Modern JavaScript has a built-in full screen API. It's very simple to use, let me show you. This doesn't need any library or anything. None of the projects in this series will use a library. All the code is just plain vanilla JavaScript. You can use this simple if-else statement to toggle full screen on and off. I will put that method here on the main game class, in the area where we put the other helper utility methods. The logic is very simple. When we call this method, it will check if the full screen is currently not active, and if so, it will activate it. Else, it will deactivate it. I want this method to run when we click this full screen button. I handle the buttons here, I copy this code block, and I repurpose it. The ID is full screen button. I need to pay attention to lowercase and uppercase letters here. I create a reference to the button element. When we click it, we call toggle full screen. When I click the button, I can toggle full screen mode on and off. It doesn't fully show my screen on the video because of the way my screen recording is set up, but if you are coding along, you can see that we just implemented a proper full screen functionality. That was easy. Maybe I also want to toggle full screen by pressing something on the keyboard. On the main game class, I will apply an event listener for key up event. Normally I would use, for example, letter F for this, but we are allowing the user to type names of the players, so I can't use any keys that can be used while typing these names. All the letters, hyphens and spacebar are excluded, and I can't use them for this. Maybe I can use plus or minus. If e.key is minus, we toggle full screen. Tapping minus on the keyboard now repeatedly will toggle full screen on and off. We also have this debug button here. I want it to toggle debug mode on and off. In debug mode, we will be able to see some helper shapes that will make it easier for us to build and test the game. But we want those things to be hidden in the final playable version. For example, game grid, snake and food hitboxes after we turn them into animated sprite sheets. Things like that. We will have a property on the main game class. I will call it this.debug. Initially, I will set it to true. Debug mode is on. If the key that was pressed is plus, we toggle debug on and off by setting debug to its opposite. I'm saying if this.debug is true, set it to false. If it's false, set it to true. I only want to draw the game grid if debug mode is on. I can do that in here, or I can do it inside render. Only if this.debug is true, only then call this.drawGrid method. I play, and when I press plus key on my keyboard, I show and hide the helper grid. We will make more of the game elements be dependent on the state of debug mode later on as we develop the game. I also want the same thing to happen when we click the debug button. Debug button, add event listener. We are inside the UI class right now. When we click it, we set debug property that sits on the main game object to its opposite. Now I can press plus on my keyboard, or I can click this button to toggle debug mode on and off and to show and hide some helper elements in the game. I can give my snakes some more interesting default name values. You can use whatever you want here if you are coding along. It's your game. Player 1 will be my name, Frank. Player 2 will be Hungry Snake. Player 3 will be Crawler. Player 4 will be Long Boy. Now these fields come with pre-filled values that are more personalized, but we can still type in there and change them from here if we want. I want to have some fun names up here rather than just player 1, player 2. We have a grid-based game. I can change the cell size and the entire game board adjusts to that value, including the snakes themselves, the food and the environmental image up top. Let's make that grid larger for now. This image became too blurry because I created it for maximum cell size of 50 pixels. We are scaling it up now and it's not good quality at this scale. So I went back, I reorganized the art assets and I exported them at a higher resolution. You can download it in the resources section below and you can include it down here in index.html. I named it forest margin repeat 1600 times 600 pixels. I will give it the same ID and I will delete the other image to replace it. The background artwork covers 3 rows. This image is 600 pixels tall, so it will work up to maximum cell size of 200, which is much more than we will ever need. This image is actually too large. I will leave it like this for now. In the end, we should resize and export all our art assets at the right size, but we haven't settled on the final cell size yet. Let's see how this goes. The main thing is that we have a nice and sharp background artwork now. It is fully scalable and it tiles horizontally to create a seamless repeating pattern. I will go with cell size 80 times 80 pixels for now. The food looks just like a boring white rectangle. Before we turn it into animated edible mushrooms and maybe even some poisonous spiky shadow creatures, let's just give it a simple image, a magic berry. You can download it in the resources section below as always. I include it in index.html and I give it an ID of magic_berry1. I'm putting all my images inside this assets div, which means they will be hidden on the web page. Inside food.js, I create this.image property. It will point to that image file using its ID. I can now use built-in Canvas drawImage method to draw the magic berry. It expects a minimum of 3 arguments: the image we want to draw, and x and y coordinates where to draw it. If we do this, it will draw that image at its original size. I'm passing it this.x and this.y, which we know are not the actual coordinates. These values determine the cell in the grid. To correctly position the food in the grid, I have to multiply these values by the cell size. The image I'm giving you is too big because we haven't settled on the final cell size yet. So if I want to scale it down to make sure the magic berry fits exactly one cell in the game grid, I have to pass drawImage method optional 4th and 5th arguments to define its width and height. The image will be stretched, or in this case squeezed, to fill the area we define here. Perfect. We have a magic berry. Now that we have an image representing the food, the white square we are drawing behind it can only be visible if this.game.debug is true, if the debug mode is on. Now I can toggle debug mode on and off by clicking this button or by pressing minus key on the keyboard. Okay, now the fun part. We will turn the snakes into animated creatures. It took me a while to figure this out, and I made it more difficult for myself because I gave the art assets shading, which means we need a different segment for left, right, up and down, and we also need 2 separate wheels for clockwise and counterclockwise turns. If my snakes were just a single color, I would need only half of this. Because the top and the bottom of the body has different shading, I made it a slightly more challenging to implement, but I think it will help us to better understand how we can connect the individual frames in this sprite sheet to create continuous snake bodies. If you have a simpler snake, for example like this shadow creature I made here, since the top and the bottom of the body has the same color, you would need only half of the rules we are about to write. It will make more sense in a minute. Let's explain it step by step. I figured out and simplified all the details for you so you don't have to. Let me show you how it's done. I included the snake corgi sprite sheet in the assets here. I gave it some ID. I give the parent snake class this.image property and I will point it towards that image using its ID. For now, all the snakes will look the same. A sausage dog. We will have to crop individual frames from the sprite sheet in a way that creates the head, body and the tail of the snake. Those body parts also have to face in the correct direction. I wanted to make this look good, so instead of just rotating the same image like this, we are going to use a proper 4-directional art for all game characters, because as always, we are going extra mile in extra style. Same as we did for food, we will use built-in drawImage method for this. Keep in mind that this block is the drawing code for a single segment in the snake body. Right now, we are drawing a simple rectangle representing each segment. I pass it the image we want to draw, the sausage dog sprite sheet, and I will pass it 4 more arguments representing x, y, width and height of the body segment. By doing this, JavaScript will take the entire image and it will squeeze it into a space of a single cell. And it will do that for all body segments. So right now we are passing drawImage 5 arguments, the image we want to draw and destination x, destination y, destination width and destination height to tell it where we want the image to be drawn on destination canvas. DrawImage method can also accept 9 arguments. Doing that will give us the most control over the image we are drawing. Those 4 additional arguments are source x, source y, source width, and source height to specify an area we want to crop out from the source image. So now we have the image to draw, source x, y, width and height to define the crop, and destination x, y, width and height to define where on destination canvas we want that cropped out piece of image to be drawn. Once you understand this, you can do anything you want with your 2D sprite sheets. Let me show you how this works. We need 2 separate sizes here. We have width and height of a single body segment. This will define the size at which we will draw the sprite frames on canvas. We also need sprite width and sprite height properties, which can be a different value. These values represent the size of a single frame in the sprite sheet. So these values are used for cropping from the sprite sheet, and these values that can be different define the size at which we will be drawing those frames on canvas. To get the sprite width, I check the width of my image and I divide it by the number of columns. To get the sprite height, I take the height of the entire sprite sheet and I divide it by the number of rows. In this case, my sprite sheet has square-shaped frames. Width and height will be the same. I exported this sprite sheet much larger than what we need it to be because we haven't decided what the final cell size will be. For now, frame in the sprite sheet will be 200 times 200 pixels, even though the game cells are only 80 times 80 pixels. We will scale the image down for now. So, source X, Y, width and height to define the cropping area. For now, I want each segment to look the same. Let's try to see what happens when we crop out this frame. The cropping area of the image is from coordinates 0, 0 to sprite width, sprite height. That worked. If I want to crop out a different frame, I can move around the cropping area horizontally using source X argument. We know each frame is sprite width wide, so if I jump by that value, we can travel around the sprite sheet and crop out a different frame. This is 0 times sprite width because 0 times 200 is 0. Cropping area will start from here horizontally. 1 times sprite width is 200. It will give us this frame. 2 times sprite width, 400, is this frame. All this time we are on the top row because source Y, the vertical cropping coordinate, is 0. I can do the same thing vertically. The combination of source X and source Y value can give us any frame in the sprite sheet that we might need. Now I moved one row down vertically to get this frame. When we create the game, we automatically run resize. We have start method down here. Since we are iterating and developing this code, I want the game to start automatically for a while, so I don't have to click on start every time I want to update the project and test my code. So I will call start method automatically here. Now, when I reload the page, the game will auto start. The game will start immediately. 5 times sprite width will move the cropping area here horizontally. 0 times sprite height will move it one row up. For every animation frame, we cycle over all the body segments of each snake, from head to tail, and we draw that segment at its X and Y coordinates. We hold those X and Y values on each individual segment object. We know that we can multiply horizontal and vertical cropping area by these values and crop different frames from the sprite sheet. I want each segment to hold its own cropping coordinate value, because some segments will be head, some will be body, and so on. So we will take this multiplier from the actual segment object. Segment.frameX for horizontal cropping position, segment.framey for the vertical cropping position. For every animation frame as the game runs, we are creating a new body segment to be added to the beginning of the snake, and we are removing the last body segment of the snake. I will give those segments I'm creating frame X and frame Y properties. I will give them initial values of 0, 0, for example, but these values will not matter because the cropping coordinates for each segment will have to be calculated for each animation frame, depending on what the snake is doing and how it's positioned. 0, 4 is this frame, 5, 4 is this frame. It's important to understand what frame we get if we give frame X and frame Y specific values. Let's make Computer 2 AI controlled by default as well for now, so we can see the snakes in motion and see what's happening with the sprite frames as they move around and turn in all directions. Only Frank is keyboard controlled. Hungry Snake, Crawler, and Long Boy are computer AI. I set winning score to 20 for now. On the snake class, as the snakes move around, we are adding new segments to the front and removing old segments from the back. I will only draw the colored squares representing the snake bodies when the debug mode is on. When I disable debug mode, we have snakes made out of magic berries. Every time the snake moves to a new cell in the grid, we have to check position of all its body segments, and we need to decide where is the head, where is the body, and where is the tail, and on top of that, in which direction they are all facing. I will write that logic inside a custom method I call, for example, setSpriteFrame. It will expect index as an argument. As we cycle over snake segments from head to toe, each segment has its own index value, and we will need it here. Instead of always typing this long thing many times over and over, this .segmentsArray index, I will put it into a shorter variable. I will call it simply segment. We are cycling over all the body segments that are stored in the array on line 14. In the beginning, each snake is made out of 3 body segments. setSpriteFrame method will run this entire code block we are about to write for each segment one by one. Let's start simple. To determine which frame we need to cut out from the sprite sheet, we need to have a position of the previous segment with index value that is 1 less than the current body segment. We also need the position of the next segment that comes after this segment we are trying to determine the sprite frame for. There are a few things we know for sure. We know that the first segment, the segment with an index of 0, is the snake head. We also know that the last segment is the tail. Last segment is index length -1, because array indexes start from 0, not from 1. If the segment is not head or the tail, we know it's the body. We have the 3 main code blocks. Now, let's expand the logic inside each block separately. Each segment object has its own frame X and frame Y values, and we are using them here as source X and source Y arguments passed to drawImage method to determine the cropping position for each segment separately, because each segment object has its own X and Y position in the grid and its own cropping frame X, frame Y coordinates. Let's say if this segment is representing the snake head for this animation frame, set its cropping coordinate to 1, 2, which is this frame. To actually see that frame, I need to call setSpriteFrame here, as we cycle over the segments. For each method, it's generating index values, so we pass that index along here, where it's expected. As the snakes move around, eventually all the segments will turn into heads, because we are not changing that value to anything else. So let's say, if the segment is last, draw it as 1, 4, this frame. Nice, we have heads and we have tails. If the segment is not first or last, we know it's somewhere in the middle. It's the body, 1, 3. The snakes already work, but only when they are moving up. For now, let's set body as 6, 0, berry, to make it more contrasting and let us know which parts haven't been set up yet. It will be helpful when we have to work out the body segments and all these corners. Okay, keep in mind that the snake is made out of individual body segments. Each segment object has its own X, Y, width and height. Every time we update the snake, we have to work out which segment is which body part and in which direction it should be facing. We know that the first segment in the array, the element with an index of 0, is the head. In which direction is the head facing will be determined by the relative position between the head and the next body segment, the element with an index of 1 in the array. We know that if this segment, which will be the head, if its vertical Y position is less than the position of the next following body segment, the head is above the next body segment. The head will be facing up, so position 0, 1 horizontally, so frame X, and 0, 1, 2 vertically for frame Y. Else, if the head is below the next body segment, we know we need the head to face down. We crop out the frame at row 0, 1, 2, 3, 4 and column 0. I'm encountering an issue that in the very beginning the snakes are too short, and if the snake body has only 1 or 2 segments, we can't always get the previous and the next segments. What's happening here is that as we create the snake, at the point when the snake is small, only 1 body segment, there is no next segment. There is no index +1 in the array and we get an error. I can bypass it in 2 ways. I can say or 0 here, just to make sure we have something other than undefined here, which will fix the problem. But for the first few frames, the sprite sheet would look strange until we have at least 3 segments, and the previous and next segment are there for us to correctly assign the sprite frames. Another way to handle this would be to immediately create all 3 segments of the snake before we even start drawing anything on canvas. This has a different challenge because we need to make sure we are not placing those segments outside the game area. When we create an instance of the snake class using the new keyword, all the code inside the constructor is executed line by line from top to bottom. So when I create length property and segments array, I can immediately fill it. I use a for loop. It will run 3 times, and each time it runs, it will move to a new cell in the grid and place a body segment there, creating the entire snake immediately. So the whole snake is there, laid out for the first animation frame. Every time the for loop runs and we move to another cell in the grid, we create a new body segment using the same line of code we will be using later as the snake moves around. So now, when I reload the game, we are creating the entire snake body for the first animation frame, so that we immediately have data on the previous and next segment positions that we need. Okay, let's finish the snake head sprite sheet. The head will be facing left if the horizontal position of the head is less than the body segment, and in that case we use frame 0, 0. The head will be facing right if the position of the head is to the right on the horizontal x-axis when compared to the following body segment. In that case, we crop out a sprite frame from the position 2, 1. Now, as I move around the first body segment of the snake, the head already works and it is correctly facing in the direction the snake is moving. We determined the position of the head because we knew it was the first element in the segments array, and we compared its position to the position of the next following body segment. For the tail, we always know it is the last segment in the segments array, no matter how long the array is, and we will determine the position of the tail by comparing it to the previous body segment, to the element that is second to last in the array. If the previous body segment is above the tail segment, we need a frame of the tail facing up. We crop out position 1, 4. Else, if the previous body segment is below the tail, we need a frame of tail down, position 0, 2. If the previous segment is to the left of the tail, we will use frame 2, 0. And finally, if the previous segment is to the right of the tail, we will use frame 0, 1. Now, if you look at our snakes, the head and the tail is always correct in any direction they move. Amazing. We made so much progress already. The middle of the snake body will be handled in this code block. These will be made from horizontal or vertical body segments, or clockwise or counterclockwise bends. We will leave this else statement here so we can see the positions of the body we have yet to sort out. It will appear as this magic berry, which is nice and contrasting, so it will bring our attention to the things that are left to do. We used next segment to work out the frame for the head, and we used previous segment to figure out the tail. Because body segments will be in the middle, we will have to consider both previous and the next segment positions at the same time to correctly determine the body sprite frame. Let's start with the simple bits. If the next body segment is to the left horizontally, And at the same time, if the previous segment is to the right, we know we have to use frame 5, 3, or alternatively 1, 1, which is the same piece but without the leg. We will discuss the alternative frames later. Now, if the snakes move to the right, the whole body is already made out of the correct pieces. So this was horizontal move to the right. If the snake was a single uniform color with no shading and with no legs, this same frame could also be applicable for horizontal left move. But since the top of the snake body is a different color than the bottom, to make the snake correctly connect as it turns and bends around, I have to flip the light and dark upside down when we move to the left. Otherwise, when we turn around, it will not connect. If previous segment is to the left from this segment, and at the same time, if the next segment is to the right of this segment, we know the snake is moving to the left. So that would be frame 5, 2. Or alternatively, also 1, 0 could be used here. Else if, here we will cover vertical movement up. Only if previous segment is above this segment, and at the same time, next segment is below this segment, we will use frame 1, 3. Else, if next segment is above and previous segment is below, we will use frame 0, 3. Also notice I had to flip the dark and light body shading to make sure it correctly connects when the snake does complicated bends and turns. Amazing, we are drawing sausage dog snakes in every direction. We can still see this frame with a magic berry when they turn corners, so that we know we need to replace those parts with these two wheels to seamlessly connect the snake body. So let's do it. I know this is a massive if-else statement, but I hope that the way we are doing it step by step is making it a little bit easier to follow and to understand what we are doing and why is it working. Let's cover the corner pieces when the snake is turning counterclockwise. If the previous segment is to the left from this segment, and if the next segment is below this segment, we know that the snake is moving up and turning left, so this segment will have frame 4, 0. I'm controlling the snake, and if I move up and I turn left, we are correctly connecting the body with the corner piece. Perfect. If previous segment is below this segment, and if next segment is to the right of this segment, we know the snake is moving left and down, so we will give this body piece frame 3, 0. I test it, I move up, I turn left, I turn down. Awesome. Also, if previous segment is to the right of this segment, and the next segment is above this segment, we know the snake is turning down and right. So the frame we will use here is 3, 1. If I move down and turn right, we get the correct connecting corner frame. Perfect. Finally, to finish the counterclockwise wheel, we know that if the previous segment is above this segment and the next segment is to the left, the snake is turning right and up, and we will need frame 4, 1 here. I will set debug initially to false to hide all these hitboxes. We can still toggle it on and off by pressing plus on the keyboard or by clicking the debug button. We have covered the complete counterclockwise wheel, so we can keep turning left, down, right, up, and again left, down, right, up, and the snake body, while doing these moves, will be seamless and complete. Because of the body shading and because one side is darker, we have to have a separate wheel for clockwise turns. You can probably figure out the rest by yourself based on what we just did. So I will do this a little bit faster. Notice that we are still in the same else-if statement. It's important to do it this way. If the next segment is to the left and previous segment is below, we are turning right and down, so frame will be 3, 2. Next, I want to cover down left, which will be needed when the next segment is above and previous segment is to the left, frame 3, 3. Else, and here we will cover left and up. If next segment is to the right and previous segment is above, we will use frame 2, 3. And finally, to finish the entire snake with up, right, clockwise turn, if next segment is below and previous segment is to the right, we use frame 2, 2. We have snakes that can turn in any direction and they can bend in any way, and all the frames will now always connect to create a seamless body. Go ahead and try some snake acrobatics. It will work no matter how long your snake is or how many times it turns. So to recap, to determine the correct sprite frame, we just had to consider the position of the previous and the next segments in relation to the segment we are trying to decide the frame for. I hope this makes sense. Maybe you want the snake to have closed mouth. We also have a frame for that. Now that you understand these code blocks and how to navigate around the columns and rows in the sprite sheet, you can try some of your own experiments. I gave the sprite sheet some extra frames for fun that you can substitute or even animate in between. Closed mouth frame is 4, 2 to the left and 6, 3 to the right. Maybe you also want a more classic snake with no legs. You can replace the horizontal body frames. Right is 1, 1. Left is 1, 0. I encourage you to play with the sprite sheet for a while and experiment with these values. If you are still not 100% clear on how all of this works, it will become more clear as we develop the project further, so don't worry. Well done for getting so far, amazing work. I hope this project is opening up your mind to some of the cool and crazy things that can be done with programming. Let's replace the static magic berry image with an animated mushroom sprite sheet. You can download it in the resources section below. I put the image into my assets/images folder. I reference it here in index.html and I give it some ID. The frames in the sprite sheet are actually 2 cells tall because I want to further enforce this view we are already creating by the artwork we use for the snake heads and for the background up top. I want the game board to create an illusion that it's seen from an angle and we are looking down from a side at the game world. And here we see more into the distance. There was this game called Heroes of Might and Magic, which used a very similar view during battles, especially the second and the third games in that series, which are by far my favorites. I'm trying to create a similar view of the game area here. The mushroom will be drawn across 2 cells in the game grid, but it will be growing from the bottom square. That's the one we will interact with. The snakes will be able to go behind the top half of the mushrooms. Having food images that are 2 cells tall gives me some extra space to play with sprite animation, and it also enforces this top-down sideways view, which I like. I replace the image here, and now that we are pointing to the sprite sheet, we know that by default, drawImage method is taking the entire sprite sheet and it is squeezing it into an area of 1 frame. We want to be able to crop out individual frames one by one to create animation. To do that, we need to know sprite width and sprite height, the width and height of a single frame in the sprite sheet. This sprite sheet is larger than it needs to be, because we haven't settled on the final cell size yet. The frames in the image I'm giving you are 200 × 400 pixels. Down here we have drawImage method with 5 arguments. We are giving it the image to draw, the horizontal x coordinate of the top left corner of the image, the vertical y coordinate, the width at which we want to draw the image on canvas, and height. The image will be stretched or squeezed to the area we define by these values. We also already learned that we can give drawImage method additional 4 arguments to first define a cropping area and then draw only that cropped out piece. This is how we animate sprite sheets with JavaScript. We define the crop by these 4 arguments: source x, source y, source width, and source height. Let's start by cropping out the left frame from coordinates 0, 0 to sprite width, sprite height. I can navigate around the sprite sheet horizontally by changing the value we pass as source x, the horizontal cropping coordinate. I multiply sprite width by the frame number, and it will give me that frame. Here we count from 0. I can toggle debug mode on. Actually, I will set debug mode to be true by default to see the white square behind the food as we write this code out. I want the mushrooms to be 1 cell wide, but 2 cells tall. I display the last frame, 8 times sprite width. I want the bottom of the mushroom image to sit over the white interaction area, the hitbox. The snake's head needs to interact with the bottom half of the mushroom image to eat it. The top of the mushroom image is just for a nice visual, and it gives me some more animation space, and the snakes can crawl behind the top half without interacting with the mushroom. The white square is the hitbox, the area at which food interacts with the game world. The mushroom reaches outside of that area further top, just to further enforce the top-down sideways view we have been working on creating today. I give this multiplier a variable name, framex. I put it here as a property. Initially it will be 0. Max frame will be 8. We know that the value we give to frame x defines the frame we are cropping out. So now I want to go from frame 0 to frame 8 to actually animate the sprite sheet. For every animation frame, if frame x is less than max frame, increase frame x by 1. This animates through the frames just once, and then we are always showing the last frame. I want frame x to reset back to 0 every time the food resets to a new position in the game grid. Now that's much better. We get a new animation sequence each time when one of the snakes eats the mushroom, and it pops out in another place. We can make the computer AI a little bit smarter. Let's take it step by step. I can start with a set of very simple rules. Computer AI controlled snake has its turn method that just makes it randomly turn in one of 4 directions: up, down, left, or right. What if, instead, I make the snake look where the food is in relation to its position, and then, based on that, it will decide in which direction it will turn. If food is above the snake, turn up. Else, meaning the food is below, turn down. Keep in mind that this block runs only when speed y is 0, when the snake is not currently moving up or down. Else, if the snake is not moving left or right, if the food is to the left of the snake, turn left. Else, turn right. The snakes move in a way that positions them closer to the food, but they only turn in a specific interval, which means they will often overshoot the row or a column, and they will not be very effective at eating the mushrooms. For that reason, I can also say, if the snake is in the same column as the food, run the turn method immediately. That method will make the snake check where the food is, and it will turn towards it. We only care if the snake head is in the same column as the food, if the snake is not moving vertically when speed y is 0. Or we also want to turn if the snake's head is in the same row as the food, and it is currently not moving horizontally when its speed x is 0. So when the snake crosses the same column or the same row as the food, it will notice that, and instead of waiting for a turn timer to actually allow it to make a turn, it will turn immediately and start moving towards the food. We will come back to this. For now, these are hungry snakes, and they can actually see the food, and they will try to eat it in most cases. Player has to be faster, and it will not be that difficult yet. This AI has some imperfections. Later, we will probably turn this into a perfect AI. that doesn't make any mistakes, but that might be impossible to win against, because computer will always have faster reactions than a person if you make it too clever. Let's see how this goes. For now, we have an AI that will look for the food and it will eat it in many cases, but it is not yet as hungry as it can be. I increase turn timer to make them turn less often. This will make them hit the wall and wait a bit longer before they decide where to turn next, and in effect it will make the game easier. It will make it easier for the players to win against the AI. I will also reset turn timer to 0 every time this block runs. I'm not fully committing to this solution, I'm just playing with the rules and will observe how the snakes behave. This AI can be improved in many ways. I will get back to this. I want to have some dynamic messages that will display a different text if we win, if we lose, and so on. For example, on the first page load, before we started the game, message 1 will say "Welcome to the battle arena." Message 2 will say "Choose your fighters." I comment this out. I don't want the game to auto-start. We start in the main menu screen and we have to click the start button to play. We can see message 1 and message 2 here. Message 1 will need larger font, maybe 30 pixels. Text align center. Message 2 will have font 20 pixels and text align center. If the messages are too long, they can stretch the entire controls panel. If I give score screen 1 pixel border, we can see that it's not centered anymore. I give it margin 0 auto to center it horizontally, and I can remove the border again. I give game menu some padding, 10 pixels maybe. To test winning and losing messages, I will set winning score to 2. I want to change the inner text of message 1 and message 2 depending on what happened in the game. I will save properties pointing to these HTML elements here on the UI class. When trigger game over runs, we set message 1 to game over. Message 2 will say press start to try again. If I use inner text property here, it will set the text inside these messages to the text we defined here. Winning score is set to 2. As soon as one of the snakes gets 2 points, trigger game over method will run and yes, we see the text on the messages. Perfect. What if trigger game over expects the winner snake as an argument? We know that each snake object has its own name property and its own score. We can use any values we store on the snake constructor inside winning and losing messages. We pass it the winning snake and we can say winner plus space wins exclamation mark. And I want the name property, so winner.name. Message 2 can say winning score space plus winner.score. So trigger game over method expects winner as an argument, the winning snake. Here, inside the snake class, we call this method. We pass it this keyword, representing a reference to this entire snake object. So we win the game. Whoever is the winning snake, we take its name and score properties, and we include them in the messages. I test it. Which one will get 2 points first? Hungry snake wins, and winning score is 2. I start another game, let's see. This time crawler wins. That worked. Trigger game over is not only called from the snake class when one of the snakes wins, we also call it when we press the restart button, and when we do that we have no winner, so we get an error. As always, there are many ways I can handle this. I will not pass it anything, but here inside trigger game over I say, if we have a winner, run this code block. Else, set those messages to some other more generic text that doesn't include the winner details. Maybe these messages could be the same as the starting messages we display on the first page load. But also, since we can detect here how exactly was this method triggered, we could create a customized set of messages for different scenarios if we wanted to. We know that this message will display when we press the restart button, for example, and we could tailor those messages to that. Okay, so I play. When I press restart, I see the messages. I start the game again, and I control my snake. When I get 2 score points, I see the winning message with my name and my winning score. Try to change your messages to something else if you want. I will set winning score back to 20. We have a complete game loop. Now it's time for fun. Okay, let's have some fun with this. I prepared different snakes for you. We can control one of the dangerous shadow creatures, the Void Wolf. You can download all art assets in the resources section below. I bring it into the project here, and I give it an ID. Now I can just reference that ID here like this, as this.image property on the parent snake class. You can also use this sprite sheet as a blank slate if you enjoy graphic design. You can give it some spike or smoke effects, for example, if you want. It's up to you. I can change the default player names to something else. How about Danger Noodle? We can also use some famous snakes. Maybe you heard about this one? Or how about this name? These are still just the default names. We can edit them here if we want. When I refresh the game, you can see that the snakes kinda skip the first cell, because we move them first and then we create a segment after we moved, so we are skipping the starting cells. I can say, only move the snake on the second round of the for loop, just to make them start from the corner cells as intended. This is not very important, but it's nice to keep it clean. Same as in the good old Snake 2 on Nokia phones, I want our snakes to open the mouth when they are about to eat something. We handle head sprite frames in this code block, and we have a separate block for each direction, up, down, left and right. I will separate each of the directions into 2 smaller blocks, because we need a head in every direction that has open and closed mouth. When the head is facing up, if the position of the food is just above the snake head, so if the food's vertical Y position is the same as the head -1, and at the same time the food is in the same column as the snake, we know we want to draw open mouth. Else, mouth will be closed. So here I find the frame for head facing up with the tongue out, else just a regular head. This block when the food is near, else in all other times just the normal head. When the head is facing down, if the position of the food is just below the head, 1 cell more on the vertical Y-axis, and at the same time the food is in the same column as the snake's head, we want open mouth frame, so 7-3, else the normal frame 0-4. So we covered up and down. When the head is facing left, we check if the food is 1 cell to the left from the snake head, and if the food is on the same row as the snake head. If it is, we show this frame, else we show this frame. And finally, when the head is facing right, we check if the food is 1 cell to the right, and at the same time, if the snake is on the same row as the food. If it is, we show this frame, else we show this frame. Now if you watch the snake's heads closely, as they are about to eat the food, they open their mouths or they stick their tongues out. I made more sprite sheets. Importantly, all of the frames are positioned in the same way, so the open mouth is always in the same position on all of them, so that we can reuse the same set sprite frame method with the same frame coordinates to animate all kinds of snakes that I'm giving you. This one I made is a poisonous sticky saberhound. Cute but dangerous. Don't touch it. I created a sprite sheet with different types of animated creatures that the snakes can eat. I know none of these look very edible, but this is a magic forest, so I make the rules. Also, one of these is not actually edible and it will hurt the snake that eats it. It will be part of a game mechanic. We can use that as an advantage when playing against the AI. I will explain that as we implement it. I reference the new sprite sheet here. As you can see, we are animating the top row, the magic mushroom. The second row is a spiky shadow snail, and the third row is a mandrake root. I animated the snail to kind of fall down, and the mandrake bursts from the ground and opens its eyes. I made these frame by frame in Photoshop this time because we are using this low frame rate animation for this project. I was having a lot of fun with it, hope you like these. We know that source_y argument passed to drawImage method will determine the vertical position of the cropping area. So if I say 1 times sprite height, we move the crop 1 row down and we see the snail. I will call this property frame_y. I declare it up here. If I set frame_y to 2, we will see the mandrake. Let's say I want one of these 3 food types to actually be poison or non-edible. So when the snakes eat it, they will lose a score point and they will also lose 1 body segment. There is a simple way to declare different food types and there is more robust, complex way. Let's do the simple solution here. Here, where I check for collisions between the snake head and the food, if we detect collision, I can say if the food we are drawing is the spiky snail, if frame_y is 1, this food is not edible. Else, it's just a regular food. We reset the food outside of this if-else block. If we eat the spiky snail, we lose 1 score point and the length decreases by 1. But I don't want the snakes to completely disappear, so only reduce the length if the snake has more than 2 body segments. So now, if I set frame_y to 1, all food items are spiky shadow snails, and the snakes are losing score points. They are also reducing in length, but to actually reflect that length in the number of body segments we are drawing, every time we reduce length, I run this comparison and I call pop, removing the last element from this .segments array, making the snake shorter. Ideally, we also want to add another form of confirmation. Maybe the snake can change color, or it can make a specific sound, or we can make the food burst into particles of a specific color. I will get back to this. I will set frame_y to a random value between 0 and 3, but we don't want decimal points, so integers, math.floor. Now we get randomly 0, or 1, or 2. I want to randomize the food type every time the food resets here. So I can remove this code repetition. And also here, because we know all these properties get values when reset method is called anyway. Now we are getting randomized food items, and one of them is not edible, and it is making our snakes lose a score point and a body segment when they eat it. We could also, for example, make the non-edible food random, so the players have to figure out what is safe to eat and what is not in the beginning of each game. AI snakes just see the food, they don't check if it's edible before they eat it. We will create a difficult AI soon. This might be the only way to beat it, if we avoid the snails and eat only what's edible. I can also make the AI avoid the non-edible food. This is our game and we understand the code. We can design the game however we like. I want to have a character choice drop-down where we can select what our snakes look like. I copy this code block. I want another drop-down here. I will call it player1 character. Label will say player1, so I delete this old label, we don't need it. This is what we get. I want controls to be on a separate line, so I will insert this code block in between them. Div is a block element, so it will push each input into its own line, like this. So here we have the character drop-down, here is the name input field, and here is controls drop-down. There will be one option for each snake sprite sheet. The value needs to match the ID we give to that sprite sheet image. Text will say snake corgi. The second one will be the ghost dog. spectral schnoodle. It's a rare breed and it's half invisible. The third one will be the void wolf. And the fourth snake choice will be the sticky saberhound. We have the drop down here. This is the name input field, and here we can choose player controls. I need to have a reference to this drop down in JavaScript. I put it on the UI class where we handle all the buttons and inputs. This.player1 character property, and I point it towards this select element. On the main game class here, we initialize player1, so this code runs when we press the start button. I create a helper variable called image. It will take this.gameUI.player1character.value from here, so value that was selected in the dropdown, and I pass that image reference as the 8th argument to player1 class constructor here and here. For now, image inside init player2 will point to the same dropdown. And we pass that image to the class constructor here and here. Player3 will also point to player1 character dropdown for now, and we pass the image here. And I do the same thing for player4. Just to test it, I want to control image on all 4 players from that one dropdown. I need to make sure that the parent snake class expects image as an argument, and we will use it here. This.image property is equal to the image reference we just passed as an argument. We also know we are never instantiating the parent snake class directly. We always instantiate one of the 3 subclasses, depending if we want keyboard controls or computer AI. I will pass that argument through on keyboard1 class, also keyboard2 class, and on computer AI class. I'm getting an error because what I'm passing as images is not actually recognized as an image. I'm passing player1 character value, which is this. Whatever we select here is the value, and I made sure these values exactly match IDs I gave to these sprite sheets down here on line 97. So this is just a simple text string. Instead, I need to pass an actual reference pointing to an image element with this ID. So I have to do getElementById, and I pass it the value from the dropdown that is identical to the ID values on the images. I copy this and I put the same line of code here, here, and here. If I select spectral schnoodle, I get an error because I need to bring an image with that ID into the project first. You can download it in the resources section as usual. I set it up here like this. Now, the first dropdown will control sprite sheets used for all 4 players. Spectral schnoodle, void wolf. Looks like it works. This is not the most robust solution, but it's a good start. I tried to simplify this code as much as possible. We are implementing so many features and I want this to be beginner friendly. Sticky saberhound? Yes, that all works. Perfect. Let's create a separate character choice input for player 2. I delete this old label. Player 2 character here, here, and here. I copy this in between the 2 dropdowns to push each one on its separate row. Yeah, we have the drop down here. Good. I copy this block again and I will use it for player 3. I delete the label, I paste the code block, and I change these to player 3 character. I put the name input field in between. Yes. And the last one. And I put this in between. So this is player 4, this should say player 3. I will give them some styling. Div with an ID of game menu is here. Inside we have player choice div, and I want to target divs that are its direct descendants. So player choice will have some padding, 20 pixels up and down, and 0 left and right. Now I target the 4 divs, one for each player. If I give them border, you can see. I give each one padding 10 up and down and 5 left and right. I remove the border. Now we have each player spaced out in its own small block of inputs. This is starting to look good. I create a reference for each character choice dropdown. So we initialize player 1 here. Player 2 will take character image value from the second dropdown. Player 3 here. And player 4 here. I choose these values randomly for each player. I press play and I get an error. It's because I made a small typo here. Player 2 character. Now, when I play, all of them look like the basic snake corgi. I select some random ones here again. Player 1 is spectral schnoodle. Player 2 is void wolf. 3 is sticky saberhound. And 4 is snake corgi. Perfect. This is going really well. I hope you're having fun. To align all these input fields, I just give game menu text align center. I noticed that I misspelled void wolf. I want to give each dropdown a different default selection so that if we don't select anything, each player will have a different sprite sheet automatically. We can still use the dropdowns and select whatever we like manually. I can choose a default selection by giving it selected attribute. When present, it specifies that an option should be pre-selected when the page loads. Player 2, I fix the spelling. Void wolf will be pre-selected. Player 3, I fix the spelling. Default pre-selected option will be spectral schnoodle. Player 4, I fix the spelling. And I just leave snake corgi as the default. Nice. When the snake head is facing left and right, currently we are using these frames. Instead, I will use frame 0, 0 when facing left and 2, 1 when facing right. With the computer-controlled snakes, the way we implemented this very simple AI, it is possible for the computer to get stuck and not being able to move. If an unlikely scenario happens when all the snakes are facing one way, let's say all of them are on the same row facing to the right, and the food spawns on the same row but behind them. The AI we wrote will not be able to deal with that, and it will just not move because none of these checks will pass in that situation. I put this line that resets turn timer back to 0 up here. Let's make the AI a little bit smarter, which will at the same time make it very difficult to win against. So after we do this, we will give users a drop-down where they can choose from 3 different difficulty options. First step to make the computer-controlled snakes smarter is to fix this. Sometimes, when the snakes are moving towards the food, their turn timer runs out and triggers a turn before they reach the food. Like this. And they turn away instead of going a few more steps where they would be able to eat the food. Let's make sure the snakes see the food in front of them and they don't turn if they are moving towards it. I will make this method return and not execute any turns if the snakes are going in the right direction and they are about to find the food. If the food is in the same column as the snake, and if the food is vertically above the snake head, while the snake is moving upwards, we know that the snake will get to the food if it doesn't turn away, so we will return, preventing the rest of the code in this method from running for that animation frame. Else if the snake and the food are in the same column, the food is below the snake, and the snake is moving down, because its vertical speed is more than 0, we also return to make sure the snake keeps going in the same direction. Else, if the food and the snake head are on the same row in the game grid, and at the same time the food is to the left from the snake head, and at the same time the snake is moving to the left, we return. And the last check, else if the food is on the same row as the snake, the food is to the right from the snake, and the snake is moving right, we return. Instead of typing this.game.food, we can create a shorter variable and use it in all these places to make the code a little bit easier to read. If the snake is moving towards the food in any direction, we make sure it doesn't turn and it keeps going in that direction until it finds the food. The snakes can now really see the food from the distance. The computer AI just became a little bit more difficult for the player to deal with. I will comment this out. I will write a more robust statement that will still make the snakes turn towards the food, but if the food is behind them in a way that none of these checks would pass, it will switch to an automatic timer instead, and it will turn in some random direction anyway. From there, it will be able to navigate towards the food as normal. This will prevent the snakes from occasionally getting stuck. First, I will write a set of statements very similar to what we did here, but I will write them out separately. I'm going to say, if the food is to the left of the snake head horizontally, and the snake is currently not moving horizontally, we turn left. All of this will have to be a part of a single else if for it to work. Else if food is to the right of the snake head, and the snake is not moving horizontally, we turn right. The difference between what I did here and what we have here is that we will only commit to this left or right turn if both of these conditions are true. The way I wrote it before funneled us into this code block. If the food appears behind the snake, our snakes can't turn on a spot and go directly back. They kind of have to go around. I'm trying to write something very simple here that will unstuck the snake when needed. I will figure it out as I go. If the food is above the snake, and the snake is not moving vertically, we can turn up. And else if the food is below the snake, and we are not moving vertically, we turn down. Else, and in this block we check if speed y is 0, and we will only get to this if the food is not above or below, meaning that it is on the same row, while the snake is moving or facing away from the food. Because if the snake was moving towards the food, the return checks up top would stop this part of turn method from running. We will randomly turn up or down using a ternary operator. In 50% of the cases, turn up, else in the other 50% of cases, turn down. Else if speed x is 0, the snake is moving vertically up or down while the food is not to the left or to the right from the snake, meaning it must be in the same column behind it. We just randomly turn left or right. This needs to be else if. I need to test this to make sure I didn't miss something in this logic. There might be a simpler way to implement what I'm trying to do here. I'm sure many of you give me suggestions and I always appreciate these. I will test this and I will have a think about it. For now, this is what I came up with. You can also change the conditions of the computer AI decision-making process yourself to see how the computer control snakes behave with the rules you give it. Basically, the idea here is move the snake towards the food. If it's not possible, make it turn in a random direction to get a better angle, and maybe from that new position in the next animation frame, we can point ourselves towards the food better. Turn interval is how often the turn method is triggered. The lower the interval, the more often will the snake make moves to position itself towards the food. If the interval is a larger value, the snakes don't check as often if they are going in the correct direction and they are not as effective at searching for the food. As you can see, a small value here just turns this into a hungry pack of wolves. It's probably almost impossible for the players to win against this AI now. The AI is checking where the food is for every animation frame, and it is taking almost the shortest path along the grid towards it. I create a drop down. I will call it AI_difficulty. Name and ID will be the same. The first option will be value of 40. The snakes will take randomly between 0 up to 40 animation frames to turn. This will cause them to point towards the wall very often, where they just look like they are thinking about their next move. These opponents will be very easy to win against. They are just slow noodles. Value 15 will be the intended difficulty for the game. I call it challengers. The most difficult AI will check the position of the food every one animation frame, so it will always be moving towards it, not making any mistakes, not having any delays, and not taking any wrong turns. The AI opponents on this difficulty have the ultimate hunger. I call this drop-down difficulty. We will only need this on the computer AI snakes. I put it here on the subclass, a property that will point towards that drop-down, and it will check and store its value. We set turn interval to a random value between 0 and the value of AI difficulty dropdown. Every time turn timer runs out, we randomize turn interval again. So if I select slow noodles, turn interval is always a random value between 0 and 40. They take a while to take the correct turn to position themselves towards the food. Compare that to the way the snakes move if I select ultimate hunger. This is just a pack of hungry wolves, nothing can stand in their way. I will make challengers the pre-selected value. When the game finishes, we are showing the score points of the winning player. Those points are also visible on the scoreboard, so instead, maybe we want to display how long it took for the first player to reach the winning score. And then, the challenge could be to get the best time possible. I will store game time in this .timer property. Inside render method, outside this code block, if game over is false, we will keep adding delta time, the milliseconds that passed between animation frames, to measure how long the game has been running for. As long as game over is false and we are playing the game, keep accumulating delta time in this .timer, like this. If I console log this timer, I get undefined because it needs some initial value. When we start the game, we set timer to 0. Now, when I press start, we are getting the millisecond values. I want to show the timer in seconds, so I will create a helper method called formatTimer. It will return the current timer value, but it will move the decimal point from milliseconds to seconds. 1 second has 1000 milliseconds. If I console log formatTimer and I started the game, we get seconds now. I give timer some starting value here as well. I want to show less decimals. ToFixed method converts number into a string and it rounds the string to a specified number of decimals. I want just one number after the decimal point. We display game over messages here inside UI.js. Trigger game over method will run, and if we have a winner, message 2 will say game time space plus this.game.timer plus space and seconds. I set winning score to 2 to test this. We play. As soon as one player wins, we see game time here. I want to show the adjusted timer value, so instead we will use this.game.formatTimer here. We play, and as soon as one snake wins, we see the game time in seconds. Perfect. Okay, particle effects. I want to create a reusable pool of particle objects, and we can make those particles burst from anywhere on the screen to highlight specific events. For example, when a snake eats the food. We can also make particles different colors if the food the snake ate was not edible, for example. It will make the game more readable and it will be easier for players to keep track of what's happening. For performance reasons, I will use object pool design pattern here. Instead of constantly creating and discarding particle objects, we will create a pool of, let's say, 50 particles and we will just take them from the pool when we need them, and we reset them and return them back to the pool when we are done with them. This approach is more efficient and avoids triggering unnecessary memory allocation and garbage collection processes in the browser. As always, particles will need access to the main game object and all the useful methods and properties we store there. Every particle needs x and y coordinates. They will be circles, so I give them radius property, horizontal speed, vertical speed, and color. Because particles will be object pool members, we need a property that will indicate if this particle object is currently free and available, or if it's currently active. Every object pool member also needs a reset method to return it back to the pool when we are done with it, and a start method to take it from the pool and activate it. Initially, free will be true. The particles are inactive, sitting and waiting in the object pool. They are free and ready to be used. Start method will set free to false. It will activate the particle, and that particle is not free because it's being used. Reset method will return the particle back to the pool and deactivate it, setting its free property back to true. When we activate a particle using the start method, we will pass it x and y coordinates depending on where on the screen we wanted the particle to start from. We will also pass it color because different events can trigger particles of different colors. Inside, we just set class properties to the values that were passed as arguments. Initially, I give speed x and speed y values 1, 1. Each particle will need update and draw methods. Importantly, we only want to update and draw particle objects that are active. Only run the code inside these methods if this.free is false, if the particle is currently active and being used, if it's not free. We move them by speed x horizontally and by speed y vertically. If the particle is active, we will also draw it. To draw a circle on canvas, we have to first call beginPath. This will tell JavaScript we want to start drawing a new shape. Built-in arc method creates a circular arc centered around x and y coordinates we pass to it, with a radius value we specify here. The path starts at start angle and it ends at end angle. We define here. I want a full circle, so end angle is math.pi times 2. Arc method doesn't render anything on canvas, it just maps a path. To draw it, I have to call built-in stroke or fill method. So this is our particle class. It is an object pool member. It has a property indicating if it's currently active or inactive. It has a method to return it back to the object pool. It has a method to activate it when we need it. And its update and draw methods only run their code if the particle is currently active. I include particles.js file down here in index.html. I make sure it comes before main.js because I will need the particle class there. We will manage the object pool from our main game class. This.particles will be the actual object pool. It will be an array that holds all active and inactive particle objects. We are creating the objects in advance and we are using them, so an important choice is how many to create. If we create too many, we are wasting memory. If we create too few, and we will keep running out. I will create, for example, 50. We can adjust this number later depending on our needs. When the game class constructor is called, all this code is executed at the point when we create an instance of the game class using the new keyword. At the same time, I will also automatically trigger a custom method I call createParticlePool. We will write that method next. After we created it, I will console log the entire pool to check if it worked. CreateParticlePool method will just run a for loop 50 times. Every time it runs, it will take this.particles array and it will push one new particle object inside. We can see that particle class constructor expects game as an argument, so I pass it this keyword because here we are inside this game class. So we create an empty array. We define how many we need. We run the method to actually create the particles. and we console log them. All of that happens automatically as we instantiate the game class. In console, I can see we have 50 particle objects in the array. I open one to check its properties. All looks good here. I delete the console log. One last piece, we need a method that, when called, it will search the object pool for the first available free particle object, and it will give it to us. GetParticle method will run over the particles array. As soon as it finds the first particle with free property set to true, it will return it. Now I just need some code that will cycle over the particles array, and it will trigger their update and draw methods. Now the pool is available and I can create a burst of particles anytime I want. For example, I want to create particles that fly from the point where the snake just ate food. Here inside snake.js, we can detect collisions between the head of the snake and the food, and I will pull one particle object from the object pool and activate it. I do that using our custom getParticle method that cycles over the object pool and returns the first particle object with free properties set to true. I assign it to this helper variable I call particle. If the method was able to find a free particle, we want to call its start method to activate it. We can see that start method expects x and y coordinates and color. So I pass it x and y coordinates of the snake head, and color will be blue. I also have to give particles some radius. I will do it here because we will be changing the radius value as we animate them, so when we start and restart, I need to set the radius value again here. I also set fill style to the color of the particle. I need to make sure I call handleParticles method to update and draw them. This block runs at a slow frame rate, so I will put handleParticles outside of that block because I want them to animate at 60 frames per second. I want smooth, fluid motion for the particles. Particles come from the top left corner, from the point where the snake head was when it collided with food. That is because this.x and this.y define the cell in the grid. If I want the actual coordinates in pixels, I need to multiply this by cell size here and here. That's better. I set winning score to 20. I want horizontal speed of the particle to be a random value between -5 and +5. Negative value here will move the particle to the left. Positive value will move it to the right. Vertical speed will be a random value between 0 and 3. Maybe I want to activate and draw more than one particle each time. I can use a for loop here. Let's say I want 5 particles each time. I can put it inside a for loop like this. I remove this console log. Perfect, we are drawing a burst of particles every time snake eats food. Eventually we run out because our object pool has 50 particle objects and we are not returning them back to the pool after we used them. I want the particles to shrink. As long as the radius is more than 0.5, reduce radius by 0.1 pixel per animation frame. Else, meaning the radius is less than 0.5, reset them and return them back to the pool. I want the particles to start from the position of the food, but from the middle of the cell where the food was sitting horizontally, so I add half a cell size to it. I also do the same for the vertical position of the food plus half of the cell size. The particles now spray out from the middle of the cell. I want speed y to be a random value between -1 and +2. Negative values will move the particles up. Positive values here will move the particles down along the vertical y-axis. Maybe I want particles to move in a different way. Let's use some simple trigonometry. Each particle will have its own angle value. We will be increasing that angle by VA, velocity of angle, and we will be mapping that increase in angle value along a sine curve. Each particle will have a different random VA value between minus 0.2 and plus 0.2. I want particles to have an alternating left and right motion, so the horizontal x-coordinate plus minus this ever-increasing angle value passed to built-in math.sine method. You don't have to understand trigonometry for this class, just understand that for every animation frame we are increasing angle value by a certain small number. Math.sine here takes that ever-increasing angle and it maps those positions along a sine curve. This value now defines the size of that curve, its radius, because without it, math.sine would create a curve between -1 and +1, and that motion would be barely noticeable. Because of the fact that we are assigning these values to the horizontal x-coordinate, it will give the particles wavy left and right motion. When we activate the particle, we always reset angle back to 0. I increase the horizontal movement radius to a random value between -10 and +10. We are starting to get more interesting motion. I want the forces to be strong at first and decay over time. I will reduce the horizontal movement range by 3% of its current value for each animation frame. It's important that we reset this value back when we restart the particle. We are doing that here on line 24. I can make the range even larger for kind of a big splash at first. I think it's clear how this value affects the particle motion. I will leave it at a range between -15 and +15. I want the particles to slowly float upwards by a very small value in the negative direction on the vertical y-axis. So now, even if they initially go downwards as the animation runs, this line will make them float and eventually go up. I want the motion to be something like fire sparks or maybe a flock of fireflies. I give it gold color. I really like the motion pattern we managed to create here. Particles are leaving strange trails. It's because we are drawing the particles 60 times per second, but we are only clearing that canvas when we update the grid-based objects, snakes and the food, which is around 5 frames per second. That's why these strange pulsating trails are appearing like this. I want to have snakes and food, the objects that snap to the game grid, to move at a low frame rate at around 5 frames per second, and I want the particles to have a smooth motion at 60 frames per second. I need to separate them out. An easy way to do that is to draw them on a different canvas element. I also want to get a burst of particles over the game over menu when someone wins the game, and we are drawing those divs over canvas. I can position the particle canvas on top of everything. To do that, I define it here after all the game menus. Assets div is hidden, so we don't have to worry about that. Game class constructor will expect the second canvas and its context as arguments. I convert them into class properties, this.canvas2 and this.ctx2. Now, all over our project, when I use this.game.ctx, we are drawing on the background low frame rate canvas. And if I use this.game.ctx2, we are drawing on the foreground particle canvas. When the page loads, I set the second canvas up. ctx2 is canvas2.getContext. I set canvas2 width and height to the same values as we did with canvas1. I want the two canvas elements to always be positioned on top of each other. Now I can pass game canvas2 and context2. In CSS, I give canvas2 blue background so we can see where it is. Right now it follows the document flow, so let's make it ignore the other canvas by giving it position absolute. Now the second canvas acts as if the first canvas wasn't there. I will actually give it the same exact CSS properties I gave to canvas1. Cool, now we can see they overlap, so I can remove the blue background. Canvas2 is now transparent and it is on top of all the other elements. So when I try to click the menus, I can't because I'm clicking on that invisible canvas. I want the second canvas to be there so that we can draw on it, but I don't want it to interact with mouse at all. If I set pointer events to none, the element will be ignored by mouse clicks and we can interact with the elements behind it. Now I can go to the particle class and through this.gameReference I can access the other context. And I can do this to draw the particles on the second canvas. Nice, that worked. You can see from these shapes we achieved a really cool movement pattern for the particles. We can see trails because we are not deleting old paint on the second canvas. Inside handle particles method, I take this.ctx2 and I call clear rectangle method. I clear it from coordinate 0, 0 to the width and height of the game area. We are not clearing the canvas around the edges because the canvas is set to size of the browser window, but the game area is a bit smaller, depending on the layout and cell size of the grid. I can just go to the resize method on the main game class. Here we set up canvas 1. Here we set up canvas 2 in the same way. Every time we resize browser window, this code will make sure that the two canvas elements align perfectly. I give the second canvas gold fill style. Maybe I want to give the particles black stroke to better match the art style we are using for this project. I set line width to 2 pixels. Here we fill the particle shape with color and we will also stroke it. This looks better. I want the non-edible food to create black particles to make it even more visually clear that the snake ate something bad. I cut this entire code block and I put it here. I create a let variable I call color and I put it up here. If the food that was eaten was not edible, we set color to black. If it was just regular food, we set color to gold. Now I pass the color here to particle start method as the third argument. We get a burst of gold particles every time snake eats magic mushrooms or mandrake root. Let's wait for a spiky snail, which is not edible. Here. And yes, we get a firework of black particles. Perfect. If the snakes are long, it might not always be very clear that we just lost one body segment and that we lost a score point up here, but the black particles make it easier to see and understand what's going on. We will enforce this even further with a special sound in a minute. I'm going to reset the particles sooner. We know that the particles are shrinking for 0.1 pixels per animation frame. When the particle's radius is smaller than 2 pixels, we reset the particle, returning it back to the pool of unused available objects. Maybe I can do even 4 pixels here. Increasing this value is good for performance, especially if we are drawing many particles at the same time. We have a particle pool in our project and we can use it to highlight anything we want. For example, we can create a special set of particles that fly out from the snake's tail whenever it loses a segment. Or I can create a big firework when one of the snakes wins the game. Here inside UI.js we have a custom trigger game over method. I copy this code block and here, if we have a winner, we display the messages and we create some particles. If I use number of particles here, it will just take all the particles that remain currently available in the object pool. I want them to be gold. You can use a different color here if you want. I set winning score to 2, just to test this. We play. As soon as one of the snakes gets 2 score points, we get a winner game over screen and particles are activated. I want them to be spread out horizontally, so start in X position will be a random value between 0 and game width. Vertically, I want them to come from the bottom of the screen. This.game.height. Let's play. As soon as one of the snakes wins, this is what we get. Maybe I want them to start from 90% of game height. Let's try. Yes, this is better. To give the game a better atmosphere and make the game actions even more readable for the players, let's add a set of sounds. Inside the assets div, here we handle the food art assets, here are the snakes, and here we will add some audio files. As always, you can download everything you need in the resources section below. I create HTML audio tag, I give it some ID, I put all my audio files into my project folder into assets/sounds subfolder, and I point source attribute towards that audio file. We are instantiating the main game class inside a load event listener to make sure all these assets are loaded and available when we run the code. I create another JavaScript file. I call it sound.js. Custom class I call, for example, audio control, and inside the constructor I create a simple property pointing to that audio file using its ID. On the main game class, I create this.sound property and I set it to an instance of the new audio control class. Now I play the game sound when snake collides with food by accessing this.game.sound, then the name of the sound property byte1, and I call built-in play method. I also need to include that new sound.js file here. When the snake eats food, byte1 sound plays. We are calling the built-in play method on the HTML audio element. It has one disadvantage. It will not play twice at the same time, and it will not play again until the first audio finished playing. You will notice that sometimes if the snakes eat too fast, the sound will not play because the previous one is still finishing. We can create multiple instances of the same audio, or we can use this performance-friendly trick. We write our own custom play method that takes the sound we want to play as an argument. And every time before we play that sound, we always rewind to the beginning by setting its current time property to 0. Then we take it and call built-in play method to play it from the beginning. So custom play method, we pass it sound, we rewind the sound, and we call built-in play method that will actually play that sound. To call it, I say this.game.sound.play, that's the custom play method we just wrote, and it expects the sound we want to play, so I pass it this.game.sound.byte1 as an argument. Now the audio will play every time, even if the snakes eat food very quickly. Much better. I made a special sound when the snakes eat non-edible food. But_food. We will play byte1 when the snakes eat something edible. If they eat the spiky snail, we will play bad food sound, like this. I set winning score to 10. I bring that sound into audio control class here. Let's play. Bad food, good food. Nice. I made a small set of game sounds to play when we start the game, restart the game, when one of the snakes wins, and when we click a button. We will need to add them as class properties here. Start, restart, win, and button. When the game is running and we click this restart button, I will play this.sound.restart. Else, if we are in the game menu, we click the start button, we will play this.sound.start. Fight. When the battle arena game starts, we get a commentator calling us to fight. 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 When we click debug or full screen buttons, we will play this.game.sound.button. When we click the buttons now, we get some audio feedback. Fight. When one of the snakes wins, we play this.game.sound.win. I set winning score to 2. Let's play. Fight. As soon as one of the computer-controlled opponents gets 2 score points and wins, we get a shocked audience sound. This is a battle arena and we have a commentator and we have audience. Fight. The byte sounds will play often, so I will create a set of byte sounds and we will always play one of them randomly. I bring all of them into the project as class properties here. Each one will sound a little bit different so that we get some variety and we don't just listen to one sound that always repeats. To randomize between them, I put all of them into an array like this. Fight. Now I call the byte sounds from that array we just created. The indexes start from 0, so index 2 is the third sound in the array. I have to bring those audio files into the project here. Fight. byte 4, and byte 5. I want this index to be random so that it plays one of the byte sounds randomly each time. I can do math.random times this.game.sounds.bytesounds.length. But there is no index 1.5, for example. We need integers, so I use math.floor to round the values down. Fight. Now we randomly get one of the 5 byte sounds every time Snake eats food. Fight. I will tweak the AI difficulty here. Challengers will turn every 0 to 20 frames. The most difficult AI will make a turn every 0 to 3 frames. If you made it all the way here, I want to congratulate you on your dedication. Leave a comment that says I did it below and I will respond. What's next? Let's use the new skills we learned in this video. Click like if you found some value.